Hello and welcome back to Roaming Earth. I'm glad you're here. Settle the room the way you like it. A corner lamp dimmed, a blanket drawn up, the small sounds of the night taking their places. Perhaps there's a fan tracing its quiet circle. Perhaps the window is cracked and the air carries a thread of cool. This is a good hour for wandering gently, for putting things down, for letting the mind follow one warm idea through the dark. Tonight that idea is a hush beneath ancient seas. We'll drift together through the Cambrian, the long inhale before the bang, the first bright experiments with eyes and armour, the seabed waking with burrows and small intentions. We'll start in the Ediacaran twilight, fronds and quilts and patient mats, and move, unhurried, into the rooms where symmetry takes a side, light becomes information, and shells learn to hold a shape. We'll touch the places that we remember, Burgess, Chengjiang, Sirius Passet, then step softly into the afterglow, where the tide becomes a swell and the sea learns new chords. Along the way, our language will stay plain and our footing slow. Where numbers press too hard, we'll set them down. Where uncertainty remains, and there is a lot, we'll admit it kindly and keep moving. Science here is not a drumbeat, it's a tide, something you can fall asleep to if you need to. For now, let your shoulders drop. Let the day recede like footprints in evening foam. The ocean is still outside the dark. It has been still in its way for hundreds of millions of years. It will carry on long after we've closed our eyes. There is comfort in that, a steady shore in the great night. If you're still awake, you're welcome to share where you're listening from tonight. A city room, a sleeping train, a farmhouse under a patient sky. But you don't have to. The story is here, and it will hold you either way. When you're ready, we'll step to the shoreline and feel that first quiet ripple of the Cambrian begin. If these night journeys are good company, you might tap subscribe to Roaming Earth, or leave a gentle note for the algorithm so it knows who to bring along next time. A single line, listening from the quiet side of the day, is more than enough. Then tuck the phone away, let the room go dim, and come back to the water with me. Before the verb there is the breath, a pause the world takes, so complete it almost feels like sleep. If we tilt our minds back through time, far, far beyond pyramids and poets, beyond mountains still unraised, we come to a shoreline that does not know us. The air is different, the sun the same. The ocean moves with a slow lunar sigh. On its floor, life lies like lace on stone, thin, supple and patient. This is late Ediacaran time, a twilight before names grew bones. A hush before the bang we have learned to call the Cambrian explosion. Perhaps we imagine it at dusk. The light slants through a shallow sea, turning dust in the water to gold. A ripple of sand, a sheet of microbial carpet, a silence you could almost hear. If you're settling in with this story and would like more quiet journeys, more oceans of soft time, you might tap subscribe or leave a gentle note for the algorithm, only if it feels calm to do so. Then come back to the water's edge. With me, the Ediacaran world might have felt deliberate. Not empty, never empty, but unhurried, composed of broad gestures rather than quick articulation. Instead of forests, there were mats of microbes that quilted the seafloor, trapping grains, smoothing the undersides of currents. Instead of the scuttling cast of later dramas, the actors here lay still or moved so slowly that motion was less a path than a persuasion. Many of the bodies had no mouths as we would recognize them, no hard joints, no teeth, just soft, broad surfaces, leafed and ribbed, a geometry of fronds and ovals pressed into the sediment. Like careful memories, you might picture fronds that rise like feathery candelabras from the mud, each leaflet repeating a motif of branching upon branching. Self-similarity the ocean seems to love. There are quilted forms, segmented as if stitched, spreading across the mat like living pillows. Some are discs, some are frilled, some curl like commas, pausing in their own grammar. An animal, if animal is the right word, could be a leaf sprawled on its side, absorbing, exchanging, humming with the chemistry of a simple life. Perhaps we are not even in animal country yet. Perhaps we are in a borderland, where categories loosen, and the ocean dreams itself into new arrangements. Waves move above. These beings anchor to microbial firmness, the background, as geologists might call it, because the mat is stable, a seafloor that stays where you left it. There are few burrowers to churn it, few grazers to scrape it away. The world is a patient palimpsest, each layer laid over the last, currents writing and erasing in a slow hand. If you pressed your fingertips into the surface and waited an age, your touch could be a fossil. We tend to speak about explosions as if they happen suddenly and everywhere, but in nature even fire has a prelude. The slow curing of wood, the gathering of oxygen, the spark nursing flame. Something like that may hold for the Cambrian, too. A long, quiet conditioning before the fast music begins. In these Ediacaran seas, conditions seem to lean gently toward futures. Oxygen, perhaps, was rising in soft pulses, enough to allow larger bodies to dream of thickness. Nutrients carried by rivers from continents that were shifting their arrangements may have whispered abundance at certain shelves. The earth turned, the tides breathed, and the chemistry of possibility ripened. We say perhaps, not to be coy, but because the old ocean does not answer questions. She murmurs them back. Rocks fold stories into themselves. Some are generous and keep impressions of the soft, like a careful bed will hold the shape of a sleeper. Others forget, and we must infer. The Ediacaran whispers are preserved, where fortune favors us, places where storms buried a community in a blink, or where delicate films formed between mat and silt, capturing outlines as if life had signed its name in clay. The result is a gallery of silhouettes. The details are subdued, the poses are serene. Look closer. In your mind's eye, there is a broad oval called, by later minds, Dickensinia, its segments repeating like the ribs of a gentle fan. It may have crept almost invisibly across the mat, leaving a faint trace, then settling again, absorbing what it needed through its surface. Nearby stand fronded forms, Charniodiscus perhaps, anchored by a holdfast, a stem lifting a leaf-like body into modest currents, the better to meet food already dissolved in the water. They do not chase, they do not bite, they endure, slowly breathing with the world. Tucked among them, other shapes, miners in this quiet choir, may have grazed softly, or filtered or simply existed as a kind of living texture. Communities of these beings, assembled into meadows, that were as calm as a held note, for millions of years, an interval our words can't carry easily. This was the way, and yet, if you listen more carefully, you might hear a rustle beneath the calm. Tiny experiments begin to show through the seam. Here and there, a shallow burrow, a hesitant poke into the mat, a narrow tube that suggests something long and simple passed through motion. Curiosity, the first insistent fingers of life rearranging the page. We do not know that these were prologues to a bustle to come, but it feels plausible that in the late Ediacaran, the script acquired verbs with more vigor. Bodies that had mostly interfaced with the world across broad surfaces may have started to divide duties to gather chemistry into compartments, to route energy more quickly, to explore up and down into the sediment, not just across it. Perhaps the tides of oxygen rose a little higher, and with them, possibilities for more active metabolisms. Perhaps the seafloor, once firm like a mat, began to be tested by little stirrings, grains loosened, surfaces unsettled. We often imagine the Cambrian explosion as a fireworks finale, the sky suddenly full of branching light. But what if, for a long while, in the Ediacaran dusk, someone was quietly collecting the wicks? Here is the paradox that guides this series of nights together. The Cambrian might not have been an event so much as a transition. Fast in geological terms, yes, but preceded by a very long inhale. The hush is not empty. It is dense with chemistry and soft negotiations, with the invention of tissues and behaviors that will later speed up. The long fuse, perhaps, smoldered across 100 small thresholds, many of which leave no hard record. Stand for a moment at the waterline of that older world. The breeze is cooler, the sky wide, the continents are arranged in a way our maps would not immediately recognize, rafts of rock drifting into swells and colliding with a patience only plate tectonics can afford. Waves smear themselves across flats studded with microbial texture, like handwriting you can feel. In the shallows, light is plentiful, but it is a simple light unbroken by towering algal forests or animal clouds. It reaches the living quilt, and the quilt, silent, persistent, reaches back. Here and there, a storm reshapes a bay. Silt slides, burying the meadow. The next calm lays another layer. Time thickens, stacks upon itself like blankets. In a human life, change is daily, and the landscape is a stage we assume is constant. In deep time, the stage is the dancer. Shorelines drift. The chemistry of the sea shifts in its ratios. The breath of the planet alters almost imperceptibly in composure and weight. We can only sense the gist. Imagine also within the living, a conversation you cannot hear. Cells signal. They negotiate who will be outside and who inside, which end will be the head and which the tail. If tail and head are even categories yet, developmental programs are rehearsed again and again with small variations, much as a melody tests itself in different keys. What begins as a pattern of gene activity might later be built into something visible, a quality that can be touched, or teeth that can bite. But here, for now, the motifs are almost entirely in the soft register, thin tissue, diffusion, modest architecture. There is a tenderness to it, as though life is learning to listen to its own boundaries. We might be tempted, from our vantage, to declare the Ediacaran primitive, to measure it against the speeds and spines ahead, but to the ocean that held it, it was sufficient. The right answer to that particular question of light and chemistry, and perhaps it was a necessary answer, an establishment of surfaces and shapes and quiet economies that later creatures, busier and more articulated, would build upon. Without quilts, maybe no burrows. Without mats, perhaps no appetite for stirring them. Without the first faint stirrings, no rush. A different kind of music also lies beneath this scene. The planet's own structure reshaping. Mountain belts rise and erode, their mineral wealth offered to rivers. Then the sea, weathering, draws down gases, releases ions, sets the table of trace metals that enzymes crave. There may have been pulses in these offerings, brief times when certain elements were more available, making novel metabolic strategies easier to try. One can almost feel the planet setting the mood, lighting, dimming here, brightening there, a patient stage manager, and in the galleries where stone remembers, we see punctuation marks. The community shifts. A kind of creature disappears from the program in one region and persists in another. Shapes once common fade to hints. Meanwhile, a new kind of trace, little meanders in the sediment, becomes more frequent, as if timid voyagers are mapping the subsurface by touch. It would be so soothing if the pattern were clear, but it is not. It is mostly suggestion, which is its own kind of beauty. Hold still with this quiet. Let your shoulders drop. The sea you are imagining is warm in places, cooler in others, its salinity a flavour that might differ from bay to bay. Clouds pass and lend a texture to the light that plays upon the water like moving silk. The beings here, call them animals, or call them something broader, are not separate from their bed. They are, in a way, a property of it, like ripples are a property of wind. They are the floor making itself breathe. Now, from that hush, look forward with a soft gaze. In time, currents will become corridors. The mat will loosen as burrowers learn to plough it. Surfaces will negotiate with armatures, soft will meet hard. Vision will arrive and turn the whole room on. Motion will sharpen into intent. But not yet. For now, we lie at the edge of the precipice, feet dangling into the almost. The Cambrian is not a cliff, but a slope. Yet from this hillside in this light, the slope feels steep, and there is a human truth hidden here too. We rarely recognize the moment before our lives change. The signals are soft, dispersed, ordinary. A habit shifts by a degree. A conversation opens a window. Later we point to an inflection and name it, label it as an explosion. Before that it was twilight, with the air so calm that even the stones seemed to breathe. The Ediacaran, perhaps, is the planet's twilight of that kind, a time when everything was both perfectly itself and secretly arranged toward what came next. So we will step gently into that next. We will notice how clocks are kept in sediment, in carbon isotopes, in the genetics of living descendants. We will listen for the crisp footfall of new behaviors. We will keep our tone low, because loudness belongs to other rooms. We will raise the lights slowly. For now, the ocean holds its breath, and we, listening at the edge, breathe with it. How do we keep time when the clocks are made of stone? If you sit beside a cliff and run your eyes along its lines, you might feel a hush descend. The way a library asks for quiet. Each layer is a page. Each page has margins of sand, sentences of silt, the occasional punctuation of a storm bed. We can't turn these pages quickly. The binding is the planet itself, and yet with patience, the story yields, not loudly, not all at once, but in increments of trust. To know the Cambrian, not as a single spark, but as a stretch of lived planetary hours, we learn the room's timekeepers. Some are tiny and glittering, some are broad and muted. Together they form a chorus that, if not perfectly in tune, is at least harmonious enough to hum. One of the smallest timekeepers is a crystal zircon, a minuscule shard grown in the heat of magma, its lattice a shelter for uranium atoms. Uranium arrives already ticking, destined to become lead by pathways we understand with a surprising intimacy. When a zircon cools below a certain threshold, it closes its doors to the world's exchange. The uranium remains inside, the lead accumulates, and the ratio between them becomes a slow spinning hand on an invisible dial. Later, when the crystal is lifted into sunlight by erosion and laid into a sediment that becomes stone, we may split it and listen. The whisper we hear is age, a number with uncertainties attached, but still a number, an anchoring digit in a sea of maybe. Zircons, scattered through volcanic ash layers like tiny clear confetti, allow geologists to place pins into the map of deep time. An ash bed within or just above a fossil community can be dated. The animals become bracketed between clocks that ticked in fire. If the ash lies below, we know the fossils are younger than the measured time. If above, older. With enough bracketing, the fuzzy shape of the Cambrian, those first tens of millions of years when plants proliferated, resolves a little. Another clock is chemical, engraved into the carbon itself. The ocean breathes with life, and in doing so, it fractionates carbon, preferring slightly lighter isotopes in the bodies it builds. When the planet buries an unusual amount of that light carbon in sediments, perhaps because life is very busy, or because oceans and oxygen are behaving in a particular way, the residual carbon in seawater, and thus in the carbonate rocks it makes, skews a little heavier. We read this as a D13C signal, a number with a plus or minus sign, a tilt. Some tilts are gentle undulations, others are excursions, sharp bends in the line. They carry names that sound like nicknames for moments in a long friendship. Near the dawn of the Cambrian, there seems to be a basal carbon isotope excursion. Later in the late Cambrian, a broad positive swell, often called spice by those who love these records. These are not stories on their own, but they are distinctive patterns, like motifs in a symphony. Match the motif across continents, and you can say softly, carefully, that two faraway rocks once lay beneath the same ocean mood. There is also the magnetism of the Earth itself, which flips from time to time in ways we understand in outline, but not in detail, so that north becomes south and back again. Lava cools, iron-bearing minerals align to the field. Sediments settle, and in their own slower way, acquire a directional memory. Stack enough of these alignments, and you see a barcode of polarity, a sequence of black and white that, compared with the global record, can further narrow an interval. Magnetostratigraphy, the art of reading this barcode, is a subtle companion to isotopes and ash. And there are rhythms, too, that arrive from the sky. The Earth's orbit wobbles and stretches with cycles that play out on predictable scales, tens and hundreds of thousands of years. These Milankovitch cycles, faint in our human lifetimes, can modulate climate, sedimentation and chemistry. In some sedimentary sequences, fine-grained layers that build one atop another with faithful regularity. These astronomical beats are recorded as a microscopic lamination pattern, like tree rings in mud. Astrochronology, the reading of those beats, is a way to assign duration to patterns, To say that a certain stack of layers is not just older or younger than another, but that it took X thousands of years to accumulate, it is delicate work, best done where the record is kind and continuous. Between all these, there is a fifth, both older and newer, the bodies themselves. Biostratigraphy uses the presence of certain fossil forms as markers. Some creatures are excellent timekeepers, because they evolve quickly and spread widely, like gossipy travelers who visit every shoreline and leave recognizable calling cards. In the Cambrian, fragments of tiny armored parts, the small shelly fossils appear early and diversify, offering a set of teeth and plates to index the lower layers. Later, more elaborate assemblages arrive, trilobites in their many guises, each with a range in time that can be diagrammed and used as rungs on a ladder. But bodies are also biased recorders. They choose where they live, and only sometimes get lucky enough to be buried in the right way. Hard parts preserve better than soft. Shallow shelves are more likely to be resurfaced by storms than deep basins. Some continents have kept their Cambrian pages clean, others have crumpled or burned theirs. Thus, a central discipline of Cambrian timekeeping is humility. We triangulate gently, knowing that every method has its partialities. From this triangulation, a picture takes shape, the boundary between the Ediacaran and the Cambrian. Our chosen threshold is marked, not by fireworks but by a trace, the first appearance of a particular burrow pattern called Trepticnus pidum. The trace is a series of probing, overlapping tunnels, like the trail of a hesitant finger, testing the seafloor up a bit, across, then slightly offset and down again. It suggests not only movement, but a mode of exploring the substrate that is more deliberate, more three-dimensional. The golden spike for this boundary, the physical marker hammered into a coastal cliff to declare, here begins the Cambrian, resides by international agreement at Fortune Head in Newfoundland. The choice was practical and poetic, a place where the trace is clear, the rock steady, the layers accessible, a place where the page turns in stone. The number next to this boundary, approximately 541 million years ago, is a compromise between clocks, a consensus with a margin. From there, time is partitioned into series and stages. Names float like soft buoys in a large bay. The Turinovian at the base, where the earliest Cambrian experiments mix with the last Ediacaran motifs. Then series that gather momentum, stages that are still, in some cases, waiting for official names, because science is careful and patient with labels that carry so much meaning. Each stage is ideally tied to a point in a rock somewhere, a specific outcrop with a specific feature, agreed upon by many eyes. These are called GSSPs, Global Boundary Stratotype Sections and Points, golden spikes among the gulls and lichens. They are as close to an official time as rocks allow. You may notice that our language, when it meets deep time, becomes a little devotional. We say boundary, standard, point, type section, as if speaking liturgy. Perhaps it is because we're trying to hold still in a moving medium. We want the clock to be a clock. We want to say 540 to 520 million years ago, with a confidence that matches a wristwatch. But the planet insists on nuance. Sediments are interrupted by storms, rivers change course. A volcano's ash, so useful as a timestamp, might not blanket every shelf. A fossil could be missing, simply because the waves that day were too strong, the mud too soupy, the scavengers too busy. So we hedge, and the hedging is honest. Within those 20 or so million years that we are calling our window, 540 to 520, perhaps a little wider, perhaps differently centered depending on the definition, diversity bends upward. It is not a straight line, it is a series of steps and terraces, morphological disparity. The variety of body plans, the architecture of fossipole, may have surged early, as lineages tried many forms. Taxonomic richness, how many kinds there were, continues to swell into the Ordovician, long after the supposed bang. This tension between explosion and long fuse is partly about clocks. Faster clocks see a bang, slower ones see a slope. The truth may be a choreography of both. Consider the famous windows, Shenzhen in China, a quiet margin where fine muds wrapped soft bodies around 518 million years ago. Sirius Passet in Greenland, older and colder, with a fauna that suggests an early pulse. The Burgess Shale in Canada, younger, around 508 million years, and exquisitely detailed. Each is a lantern hung along the path, and because a lantern illuminates its own halo and not the entire forest, we must resist the temptation to treat one glow as the day's shape. When the lamps line up with isotope motifs and magnetic barcodes and ash clocks, we exhale a little. When they don't, we go back to the cliff and read again. Geologists, quietly romantic despite their hammers, often speak of correlation, a word that in this context means relationship without causality, pattern without presumption. To correlate two sections means to decide that this page and that page, perhaps thousands of kilometers apart, tell the same chapter of the ocean's story. We do it with fossils, with chemistry, with polarity reversals, with ash. We clip transparent paper over each outcrop and trace, then lay the tracings atop one another, looking for harmonies. Where the outlines fit, we lean in. Where they don't, we consider whether the story was local, whether a current shifted a little differently here, whether a shelf sank slowly there. A global ocean is not a single room. It is a mansion of connected chambers. Even the word million takes on a new demeanor in these halls. In a human story, a million appears only when we look up. Cities, stars, insect swarms. In geology, a million is the smallest comfortable seat. 10 million years is an episode. 20, a season. We adjust our breathing to this tempo. Long, slow inhales. Long, slow exhalations. The Cambrian, compressed in schoolbook diagrams into a coloured band, expands under this breath into thousands upon thousands of stacked days, each with tide and cloud and silt. The explosion, then, may be more like a long summer of storms, not continuous thunder, but many afternoons when heat built and the air released. What makes a clock feel trustworthy is not that it is perfect, but that its imperfections are known. The uranium clock can be bothered by lead sneaking into a crystal late or by damage to the lattice. Isotope records can be reshaped by fluids the rock met long after burial. Magnetism can be reset by heat. Orbital rhythms can be overprinted by local currents. To keep time in deep time, we speak to each clock in its own language and ask it what it is good at. Then we bring the answers into a circle and let them talk. When the voices overlap, the hour is clearer. There is a gentleness in accepting this. It allows us to stand beside uncertainties without panic. It also invites a different kind of wonder, the kind that appreciates a number like 541 million years as both a triumph and a poem. The tilde is the poem. It says we have approached the cliff with respect. We have counted zircons and traced burrows. We have matched the rise and fall of carbon to seas that once covered continents. And still, because the ocean is large and patient and we are small, we leave a breath of air around the figure. Sometimes a new ash bed is found in an old formation, and the breath changes. A date is refined. A boundary that had seemed to sit at one height in an outcrop is nudged a little higher or lower. Papers are published. The community discusses, kindly but carefully. The timeline is redrawn in pencil, then ink. The world outside does not notice, and that is fine. Inside the library of rock, a clock has been tuned. If we slow further, we can listen for how the clocks were felt by the animals themselves. Of course, they did not know years, let alone millions. Their time was current, hunger, growth, season. But their bodies, in their development, kept time internally. Genes turned on and off in rhythms. Segments added one after another. Eyes patterned in precise lattices. These were clocks in flesh. The developmental hourglasses that, when altered by mutation or by environment, offered evolution a new tempo. A longer larval stage here, a faster segmentation there, a shift in the timing of when armor forms. Timing can be innovation. The clocks in the rock and the clocks in the body together, they compose the Cambrian's tempo. One is exterior and grand, the other intimate and silent. Perhaps it helps to hold an image. A shoreline at dawn, with a cliff of layered shale rising slowly from the surf. Along the face of that cliff, thin bands lift and fall, slightly wavy, as if a hand had drawn them by feel. In one band, a shadow of a body, flattened but eloquent. Above, a smear of ash, glittering if you catch the sun at the right angle. Within that smear, hidden tiny zircons counting silently. Elsewhere, a drill core labels the layers. Samples are bagged, brought to labs. On a screen miles away, the isotope curve wiggles like a soft heartbeat. A paleomagnetist measures a polarity and draws a thin black rectangle in a column. A biostratigrapher circles 3 trilobite heads with a pencil. Nod. Slowly an age appears, as if emerging from fog, not exact, but exact enough to tell us whether this dawn was early or late in the Cambrian morning. If this feels like ritual, it is because rituals are how we handle scale. The Cambrian asks for both humility and hospitality. It says, "Come in, but remember your size." It says, "Listen to stone with the same care you would give to a friend who speaks softly." It says, "Clocks can be trustworthy even when they are not rigid." In that softness, the explosion becomes something we can hold. Not a bang, but a brightening. Not a single second, but a chorus of overlapping intervals, each with its own timbre. So when we say 540 to 520 million years ago, let it be with kindness toward the clocks. Let it be an invitation rather than a verdict. In the next steps, we will meet the stage more closely. The chemistry of seas, the oxygen's quiet rise, the shelves where mud told stories, the nutrients washing from mountains, as if the continents themselves wanted animals to try new tricks. But for now, we honor the instruments and the hands that read them. We glance at the little zircon in its mount, glittering like a star caught in glass. We run a fingertip along a ripple mark in stone and feel the ghost of a wave. We look at the thin, looping burrow that once was a decision, a living thing choosing a direction, and we keep time, gently, with the slow breath of the planet. Before we meet the creatures with their eyes and barbs and quiet astonishments, we linger with the room itself. The theatre sets its light before the players arrive. Curtains breathe, dust motes drift and become galaxies. The ocean, too, prepares, not with intention but with mood, temperature, chemistry, the slow arrangement of shelves and sills, the long breath of oxygen rising and falling like sleep. If the Cambrian felt, to later minds, like a sudden burst of novelty, it may be because the stagehands sea, sky, stone had been working for a very long time behind that velvet. We stand at an ancient shoreline. It might be warm, the kind of warmth that relaxes shoulders. The tide creeps over a broad, shallow platform, what geologists might call an epiric sea, a continental shelf drowned by a patient rise. Transgression is the gentle word. Seas moving inward, making archipelagos of uplands, turning plains into quiet bays. Shallow water spreads like a sheet. Sunlight reaches deep enough to write its handwriting onto the sand. And storms, when they come, comb the floor with long teeth, and then remorseful, lay it smooth again. Where shelves are wide, life is offered real estate. Room to try things. Currents can be modest yet steady. Nutrients can arrive from rivers that meander like thought. Sediments can settle into layers that remember. In the late Ediacaran into the Cambrian, something like this may have been true across many margins. The planet, rearranging its continents, had created a lacework of new coasts, capes, and shallow basins. As plates drifted and collided, fresh mountain belts rose and weathered, feeding rivers with the ions that make ocean chemistry hum. Calcium wandered seaward, magnesium kept it company. Phosphorus, a little miserly in most eras, leaked from rock with moods of generosity. Trace metals needed by enzymes, tiny cofactors, keys to quiet locks were carried grain by grain, drop by drop into salt, the oxygen story. Perhaps the most delicate of the stage lights. For a long time before, oxygen was present, made by photosynthesizers who had already transformed the planet. But it may have been patchy in the seas, higher above, lower below, a stratified breath. In the run-up to the Cambrian, evidence hints at a series of pulses, not a single switch, but several, the ocean's redox boundaries flexing, oxygen pressing into places it had been scarce, then perhaps retreating, then advancing. That matters to bodies, with more oxygen at their disposal. Metabolisms can burn a little brighter, can afford tissues thicker than diffusion alone would comfortably sustain, can experiment with movement that asks for more energy per second. But it would be too neat to say oxygen rose and animals bloomed like an on-off lamp. The light was probably dappled, the surf zone airy, the seafloor oxygenated here and anoxic there, mid-waters in some basins, prone to soft suffocations that later centuries would label minimum zones. Picture it like this: a cross-section of sea, colours from pale blue at the surface to umber near the mud. In shallows, waves stir air into the skin of the water. Closer to shore, blooms of microbes draw down carbon by day, bubble oxygen like a soft champagne. Out on the shelf, clarity varies, sometimes glass green, sometimes tea dark, with river tannins. Down in the sediment, centimeters below the surface, oxygen vanishes into reactions that feed bacteria. Then below that, other chemistries take over, iron and sulfur trading partners, manganese stepping in, the quiet barter that turns mud black or rusty depending on the ratio of breath to burial. Within these gradients, small worms, some of the first busy burrowers, will eventually tunnel and twirl, pulling air into mud and mud into air, altering the script. But in this early setting, the gradients are mostly natural, laid down by physics, not yet edited much by the living. The stage hums at its own tempo. Chemistry sets prop tables. Carbonate saturation, the ocean's ease with precipitating limestone, matters if you dream of making a shell. When calcium and carbonate meet in sufficient concentrations, they marry into solidity. The shape of that marriage is sensitive to temperature, to the ratio of magnesium to calcium, to the rate at which fresh ocean is exchanged with water in the crust at spreading ridges. In some intervals, the seas have been friendlier to aragonite, in others to calcite, the mineralogies like dialects of the same language. If, during Cambrian times, the waters leaned toward aragonite-friendly moods, then creatures that decided to mineralize might have found it a little easier to choose that form, or perhaps they did not choose exactly, but were steered by the chemistry under their feet and in their blood. Skeletons in this telling are not just inventions, they are collaborations with seawater. Silica, too, moves in whispers. Sponges, quiet architects with bodies built on glass spatules, use dissolved silica to strengthen themselves. In periods when silica is plentiful, cherts may form, and the sea may welcome sponge forests that filter vast quantities of water, clarifying the shallows and changing the way light behaves at depth. Whether the earliest Cambrian had high silica to spare, or was already being sipped by growing sponge lineages, the exact balance is a matter for careful hands and thin sections. But one can sense that the competition for these invisible building blocks, silica, phosphorus, iron, would set the grain of the environment the way wind sets the grain of a dune. Sulfate, the oxidized sea-friendly form of sulfur, likely became more abundant as the planet settled into oxygenation. That shift would have invigorated the so-called sulfur cycle, microbes that breathe sulfate, turning it to sulfide, making pyrite in the mud, and in so doing tying oxygen consumption to the pace at which organic matter is buried or respired. Sulfate-loving microbes do not have faces we can draw. Their drama is the gentle theft of electrons, a chemistry opera under our notice. But their work shapes the color of muds, the smell of tidal flats, the efficiency with which carbon returns to the air or stays in stone. Many little decisions, and a world-scale outcome. The stage is sensitive to whispers. And then there is nitrogen, the currency of growth, the backbone of proteins. In waters enriched by riverine input, blooms can flourish. In waters starved, bodies must be modest. The balance between nitrogen fixed from the air by specialized microbes and nitrate, returned to the sky by denitrifiers, this invisible accounting would have modulated productivity. Productivity feeds oxygen but also consumes it below when blooms sink and rot. A dance then. More life encourages more breath, but also more shadows where breath is used up. This slow choreography sets corridors and cul-de-sacs for animals that are only beginning to take advantage. From continents, the weathering songs continue. When mountain belts are young and steep, rain chisels them with urgency. Ions flow faster to sea. When they are old and low, rivers wander and hymn rather than race. In the Cambrian neighborhood, Plate tectonics seems to have offered both, fresh ridges in places, elder highlands in others. This mosaic creates contrasts. Where the river plumes enter the shelf, clays and silt cloud the water. May be good for certain filterers, less good for those who crave clarity. Elsewhere, along carbonate platforms set away from heavy inflow, water can be startlingly clear, making vision when it arrives worth the metabolic expense. Even before eyes, light matters. It governs photosynthesis, sets circadian hints, warms the skin of the sea. Storms, always the sculptors. Without forests on land to grip soils, without the deep-rooted binders of later ages, rainstorms can strip slopes, and hurricanes, whatever their Cambrian counterparts were called, can build cohina bars of broken shells, can push sands into bars and tongues, can bury entire communities under a sigh of silt. The sudden burial is tragedy in the moment, and preservation in the long run, taphonomy's bargain. The stage in battering takes notes. We might also glance outward, to the shape of basins and the gates between them. Ocean circulation, large and small, is less a single conveyor and more a weave. Sills at the edges of basins can trap denser waters below. Wind fields can drive up welling that exhales nutrients at certain coasts. The opening and closing of seaways, narrow straits that today would make good postcard views, can alter the routes by which heat and salt are shuffled around. In some Cambrian basins, the deep might have kept secrets, low oxygen layers, rich in dissolved iron, or sulfide, lying in wait to mix, occasionally with shallower waters, and change the rules of who can live where. Quietly, no trumpet, just a gentle boundary sliding. Against this background, the actors-to-be are not pressing at a door, they are being invited into a room that has been redecorated a bit. The background, those thick microbial rugs of the Ediacaran, still exists in places, but it is fraying, tested by early burrowers. The sediment, newly oxygenated near its skin, permits different metabolisms to sit beside one another, oxidizers and reducers, neighbors whose chemistry makes gradients that others can use. Surface tension, microtopography, the stickiness of the seafloor, all change as microbes are ruffled, as grains are turned. On such subtle changes, vast repertoires behavior can be hung. Grazing, filtering, hunting in slow motion. Even the color of the water may be shifting in certain shelves, from green-brown to blue-green, depending on plankton composition and dust, depending on how quick the river pulses are. Color is not just beauty, it is information. It sets the palette that minds, when minds are later able, will paint images upon. Vision, when it evolves, will have context, distance at which contrast is useful, wavelength that penetrate, patterns of glint and shadow. Before eyes, perhaps sensitivity to light and dark is already a quiet instrument, timing day and night, depth and dawn. The stage teaches before the actors know they are learning. Temperature, another key dimmer. The Cambrian climate may have leaned warm, perhaps greenhouse enough that polar caps, if present at all, were shy and ephemeral. Warm seas do many things. They stratify more easily, making layered oceans with less mixing. They speed chemistry and the heartbeat of small animals. They move water through the global engine in patterns not exactly like ours. Warmth is generosity with a catch. It invites exuberance and also tests breath. In a warm, calm basin, the deep can go still, and in stillness, oxygen vanishes. So the stage offers both playground and trap. Underfoot, the crust itself participates. At mid-ocean ridges, seawater percolates through new basalt, exchanging metals, cooling magma, altering global ratios of magnesium and calcium in ways that ripple, slowly, into which carbonates are favored. On the flanks, hydrothermal vents puff chemistry into the dark sources for those who will later live by chemosynthesis. Gardens with no sun. We often imagine Cambrian life as a silhouette against a bright shelf, but there may also have been communities in the night, nourished by the Earth's inner breath. These too are stage lights, infrared perhaps, in our gentle metaphor, warming corners unseen. All of this is a reminder that environments are not static backdrops. They are lively, responding to feedback from the living. As soon as burrowers begin to irrigate the mud, the chemistry changes. As soon as grazers begin to nibble microbial films, the films retreat in places and advance in others. As soon as a skeleton appears and breaks, beaches feel new textures under storm. As soon as a sponge forest clarifies water, light pushes deeper and invites photosynthesizers to try a new depth. The stage is the dancer, and the dancer alters the stage. We are tempted to look for single causes, because single causes are comforting. They carry the illusion of control, of story. But the Cambrian stage reads like a polyphony. Oxygen's rise may have been necessary, yet not sufficient. Calcium's generosity may have been influential, yet not commanding. The spread of shallow seas may have been permissive, yet not decisive. Together they compose a chord, one that when it rang long enough, made certain melodies more likely. In such a chord, small innovations can be heard. A gene network in one lineage finds it easier to add a layer of cuticle because the water is ready to give it carbonate. A lava floats longer because currents hold it safely over shelves rather than casting it quickly into deep. And in floating learns a new trick of dispersal. A predator's sensitivity to light becomes a meaningful advantage because clarity has crept a little further out from shore. Possibility accrued. If all of this feels gentle, that is because it likely was, in the sense that geology prefers long arcs. A pulse of oxygen here, a slow chemical swing there, a sea level rise measured in lifetimes that would have seemed unhurried even to the creatures who lived them. And yet, across a few tens of millions of years, these gentle tilts can change who gets to exist. Ecosystems on shelves begin to cycle faster, supporting food webs that are more entwined. Niches multiply in a dimensional way, across the surface, into the sediment, up into the plankton. The macround's two-dimensional grazer becomes a three-dimensional burrower. The drift becomes directed motion. Each is an environmental story first, about gradients and scaffolds. Stand again at our shoreline. The wind shifts, very slightly, and the smell changes. The mineral note of a distant storm, the sweetness of a bloom offshore, a gull, or its Cambrian equivalent. A thing with a very different plan casts a shadow. Waves tick the stones. If you crouch and scoop a handful of water, let it run through your fingers, you might imagine the ions as characters themselves. Calcium eager, magnesium steadier, bicarbonate pliant, phosphate coy. They find each other and part. Meet again. In the mud, a filament of bacteria moves almost invisibly toward a filament of food. Above, the surface glitter acts as a ceiling, bright but not too bright. The curtain, in other words, is up. The orchestra has tuned but not yet played the opening theme. The room itself, its air and acoustics will decide which notes carry and which fall. When we turn, next to the architectures that emerged, lines of symmetry, front and back, the first clear dialogue of left and right, we will remember that those decisions are not abstractions. They are solutions to a particular set of physical questions posed by this exact sea with this exact chemistry. The stage whispers, and bodies learn to answer. For a moment longer, listen to that whisper, a long exhale from an old world. Before spines and spicules, before the glitter of eyes and the rattle of armor, there is a quieter choice. A body makes. Which way is forward? The ocean presses lightly from all directions, but an animal, if animal is what we're beginning to become, must negotiate directions within itself. Up and down become dorsal and ventral, back and belly, front and back, head and tail, left and right, a mirror that is almost but never perfectly true. These are not just words, they are coordinates. The living learn to carry. Some beings, older in the story, kept to a different geometry. The jelly-soft Medusei and their kin, creatures whose names, when later given, will include ctenidarians and ctenophores, often express themselves radially. They are spokes around a center, petals around a mouth. Spin them slowly, and they look more or less the same from many angles. They are beautiful maps of symmetry that suit a life lived in currents, where food and danger can arrive from anywhere, and your best posture is openness. A nerve net whispers around the circumference. Muscles gather in rings and sheets. A body like a lantern, light shining out evenly. Bilateral symmetry is another strategy, a decision perhaps to prefer one axis to let the world have a front. It might have begun as a softness, a preference to move a certain way, to follow gradients of smell or light, to touch and then a longish body glides. A front end meets what is new first, a back end follows. Soon enough, front becomes a place worth investing in, a denser whispering of nerves, a cluster of sensors, a reinforcement of muscle. The body reads itself from head to tail, like a sentence. The world in turn reads the body's intention. This geometry, which we call bilaterality, is more than mirror halves. It is the empowerment of a plan, maps of inside, outside, top, bottom, left, right, front, back, that coordinate every cell. In embryos, we speak softly here, imagining ancient embryos by looking at modern ones. There is a choreography that seems to recur. A single-layered sphere folds in on itself, a sheet becomes a cup, and a mouth-like opening, blastopore is the later word, leads to a hallway that will become a gut. 2 layers of tissue are not enough for the ambitions that are rising. Somewhere in this origami of living matter, a 3rd layer slides into the story, mesoderm, the stuff that will make muscles, some skeletons, connective tissue, complex hearts, triploblasty perhaps, is the quiet threshold. 3 layers negotiating. With 3, you can brace. With 3, you can tuck organs into cushions. With 3, you can make a tube within a tube and let fluids flow. Fluid is a revelation, a body cavity, a coelulum or something like it. Allows the gut to wriggle without dragging the skin. It allows soft hearts to push against something that answers back. It gives a place for eggs and gametes to mature. It makes a hydraulic world within the skin, where movement is not just muscle on ground, but pressure traveling, chambers filling, lavers pushing. Not every lineage takes the same route. Some keep the space narrow, some let it widen into rooms, but the general idea, the liberation of organs inside, may be one of the Cambrian's quiet triumphs. Once you carry a front, you are invited to carry a story about before and after. The mouth tends to the world ahead, the tail to what you leave behind. Sensation shifts forward, decision-making gathers near it, and cephalization, a later word for head building, becomes a trend. It does not have to be dramatic. A simple swelling of nerve cords near the front is already a beginning. Eyes, or proto-eyes, or light-sensitive patches find the front convenient. Antennae, palps, feelers. The world is met, tested, tasted. The body's symmetry is now a way of paying attention. This is all easy to say and hard to prove in stone. Soft tissues, the architecture of layers, the hush of early brains are reluctant to leave us notes, and so much of our sensing comes by inference and by analogy. The trackways, those looping, probing meanders attributed to bodies like the author of Triptychus Pedum, are written by something that knows front from back, that explores with intention, that returns to a central gallery and then forays again. The shape of a scratch, the pattern of overlap, the rhythm of a curve, these become a grammar from which we infer a geometry within the body that made them. Under the skin of the future, development hums. Certain genes, ancient, not owned by any one lineage, seem to play the part of signposts. The Hox family, often spoken of in hushed tones, because of the elegance of their arrangement, appears to set a rough map. What is front? What is mid? What is back? They do not draw the body, they tune an orchestra that draws the body. There are others too. Once signaling, whispering about axes, BMP and Chordin arguing softly over back and belly, Notch speaking like a metronome. Hedgehog, a whimsical name for a serious messenger setting gradients. These toolkits, or parts of them, probably predate the Cambrian. Some analyses suggest they were already in place, in simpler bodies, waiting for the stage to invite complexity. When the invitation came, the old tools wrote new scores. Segmentation, another motif that might have found a hospitable room. To repeat a unit along a line is a way to grow and to specialize at once. A worm-like body could add segments like beads on a string, each capable of its own tiny behaviors, and later, some of those segments could become different. Limbs here, gills there, Jaws in another lineage, plates in another. The logic of repeating and then differentiating is powerful because it allows evolution to experiment with a copy while keeping the rest functional. In some bilaterians, segmentation is clear. A million miles away, think of a centipede's marching symmetry. In others, it is subtle, written in neurons or muscles you would only see by taking a body gently apart. The principle, not the appearance, is what matters. If you could lift the living mat of the Ediacaran Sea and peer as the Cambrian dawn begins, you might find tiny bilaterians testing this playbook. Some are simple, perhaps flat, acello-like, no big cavity within, just tissues and a small, straightforward digestive lane. Some carry a little cavity, a pseudo-calole, a false chamber that nevertheless makes movement smoother. Others are on their way to building a true calole, a cavity lined by mesoderm that allows a kind of internal conversation between organs and muscles mediated by fluid. It is not the names that matter. It is the fact that new dimensions of motion are becoming available. A flat grazer can keep to the skin of the world. A burrow with a fluid-filled inner corridor can push, wedge, inflate, and glide into the third dimension, making the mud a livable space. With bilaterality comes a particular intimacy with the substrate. Radial forms can sit and wait. Bilateral forms, even if slow, are biased to go. They follow gradients. Oxygen leaking upward, sulfide leaking down, like a blind tasting of a layered soup. Linear bodies suit linear decisions. A little cilia-driven glide becomes a muscular undulation. A gentle undulation becomes a purposeful thrust. Over time, swimming is not just possible. It is economical. If you arrange your segments, your muscles, your internal fluid properly, the curve that travels like a wave down a worm's side is not just pretty, it is mathematics inscribed in meat. A nervous system in this geometry also finds a new coherence. A neck can be enough when inputs are everywhere, but for an animal with a front, a pair of longitudinal cords running head to tail makes a direct path for signals. Cross connections, the ladder rungs, keep left in touch with right. In some lineages, that arrangement lies belly side, in others back side. Later we will call the first protostome and include arthropods and annelids beneath that banner. The second, deuterostome, are home to chordates and echinoderms in their strange life cycles. These are large, simplified bins, useful maps, yet imperfect. Even the famous textbook line, mouth first, mouth second, is an overstatement. Development is more baroque, with variations and exceptions that argue for caution. Better, perhaps, to say that different lineages found different solutions to similar topological problems, and that those differences echo through the Cambrian. Cephalization gathers subtle drama. When sensing is forward, it is tempting to guard it. Cartilaginous sheaths, thickened cuticles, partial housings around clusters of nerve cells. These are small beginnings of protection that later become helmets. Carapaces, skulls, a mouth near sensation is an efficient arrangement. A ring of muscles, a tongue-like fold, a set of papillae, small structures that test and manipulate. If in some lineage, chitin is available, or a calcium-based scaffold is invited by the water's chemistry, teeth can be encouraged to appear in miniature. Plates to grip, jaws to hinge. The line from thin, soft lips to a gnathic bite is very long, but the geometry of front makes it imaginable. Left and right, so charmingly alike in a mirror, are also an axis where small asymmetries can be written. The heart in some deuterostomes, for instance, will favor a side. Twisting guts will choose a direction. Organs doing similar work can oppose one another and thus share the load. Gills paired, limbs matched, developmentally. Molecules will bias this mirror. Nodal-like whispers, lefty-like counter-whispers in some living lineages, softly declaring a preference. In the Cambrian, this biochemistry is not recorded in stone, yet the consequences are hinted at wherever bodies show bilateral arrangements of parts. All of this could feel schematic, like a chalkboard. So let us step back into the water and breathe there a moment. You are an early bilaterian, perhaps small enough to live between grains. Above you, light is more felt than seen. It glows as a general direction. Around you, the world smells faintly of salt, sulfur, and something green. Your body is a velvet tube, its surface ciliated a river of hair that strokes you forward at low energy cost. Inside, a simple gut processes a film you graze from the sediment, a flavor that combines bacterial tang with the carbohydrate cloth of the mat. When you meet a patch that tastes wrong, too reduced, too foul, you turn not as a thought but as a reflex couched in chemistry. Front is where chemicals arrive first and where the muscles know to pull more carefully. When a storm layer buries your meadow in a thin veil of silt, you push. A gentle swelling travels down your body, a pressure wave that nudges grains aside. You are out. You are free. Behind you, a small trace curls, a signature of presence. Now, imagine that a neighbor, by mutation or by random developmental variation, has a slightly thicker mid-layer of muscle. The push is a touch stronger. That neighbor reaches a pocket of oxygen sooner, feeds longer, leaves more eggs. In another family, the cilia are fewer but longer, slower strokes, but each carrying further. In another, light sensitivity is biased to one end. Dawn is felt as an invitation to rise from the sediment into the film, where food is newly rich. Over a population, over many lifetimes, such small tilts accumulate. The geometry of the body amplifies. Then, in a lineage or two, a structural experiment, a protein in the cuticle prone to hardening, a membrane that invites calcium in and stores it in vesicles, a secretion that makes a plate so tiny you could miss it. The body learns to carry a little burden in exchange for becoming a little less edible. To keep moving, muscles refine their dialogue with the hard bits. Joints, even tiny and gummy at first, are born. The ghost of a limb dances at the edge of possibility, even in lineages that remain soft. Bilaterality is a grammar for niches. Flattened bodies slide under the interface of water and sediment, living in the lamina of oxygen. Thread-like bodies dive deep where chemistry suits them, turning sinuous as water in a pipe. Others lift slightly above the floor, making low canopies that capture drifting particles. Up in the plankton, the universe of floaters, larvae with bilateral tendencies can steer a little toward or away from light, finding the right layer of temperature or salt. A developmental program might allow that larva to settle and invert relationships. A belly that knew the sea becomes a foot that knows the rock. At every scale, front-back provides a lever for choice. We may smile, gently, at how much of this is inference from living descendants. The fossil record shows us trilobites later, arthropod cousins in glorious detail, worms in outline, oddities that defy comfortable bins. It shows us more rarely the anatomy of the very small, but not often enough to narrate each step. So we triangulate, genetics suggesting an older toolkit, traces implying intentional, repeatable movement, glimpses of muscular phantoms in exceptional preservation telling us that the three-layer body had already been practicing. The feel of the room suggests that the script was well underway before the applause we call explosion. Where does symmetry come from? In the mind of a cell? Perhaps from gradients, chemicals diffusing across a field, establishing more here and less there. Perhaps from tensions, cells pulling on one another, listening to stiffness and aligning. Perhaps from polarity inherited from a fertilized egg's first partition. These are universal strategies, not just in worms and arthropods, but in leaves and roots. The Cambrian borrowed nothing from plants, of course. It is simply that life likes the same mathematics in many registers. In time, bilaterality will branch into lineages that seem like separate worlds, those that molt a cuticle to grow exterosomes, those that sometimes carry ciliated larvae and weave a different kind of shell logic, spiralians, lophotrotozoans, those that will give rise by meanders and miracles to fish and us, deuterostomes. In the Cambrian, the distance between these is not as theatrical as it later appears. Their common heritage a long axis with a story along it, a third tissue layer doing heavy lifting, a nervous system with an opinion binds them like siblings. After a page dense with architecture, we rest our eyes. The sea, which has tolerated our schematics, asks us to return to sensation. Sand sifts through fingers. A ripple train slides under a grazing film. The sun, kinked by waves, paints thin snakes of silver on the shallow bottom. In the near distance, a frond sways, a survivor from the older symmetry, still graceful, still valid. In its shade, a smaller, bilateral creature pauses, then leans forward into its own future. The line down its body, invisible to us, is everything to it. It is not aware of axes or terms. It only knows that one end feels like arriving. We will meet particular bodies soon. Eyes that quite possibly changed the room, shells that made habitats into armories, spines that turned touch into consequence. But it helps before that to remember the invisible grids that hold such splendors in place. The Cambrian's dazzle sits upon simple coordinates, whispered in embryos, negotiated with seawater, strengthened by behavior, left and right, top and bottom, front and back, a cross drawn in water, and a life that learns to follow its lines. Before teeth, before speed, there is a glance, light, which has always been there, falling on waves, stirring the moods of algae, sketching the day upon the water, enters the animal story in a new way, not merely as warmth, or as the quiet metronome of dawn and dusk, but as information shaped and read. Perhaps the sea is milk glass green this morning. Sandbars comb the shallows into long pale lines. The first few meters glint with flakes of motion, the planktonic haze, the sifting of a thin current. Look down and you notice a limit to your sight. It fades into soft color, red disappears first. Absorbed within arm's length in crowded water, blue lasts longest, slipping deeper, making the underlayers a cool cathedral. Light is not simply on or off here. It is a gradient, a spectrum, a texture. To make an eye is to accept those terms, to negotiate with water as much as with physics. Before eyes, there were eye spots, little patches of pigment, married to molecules that change shape when a photon strikes. These are humble, exquisite devices. A sheet of cells can become a compass if it knows that one side is darker than the other. Add a dab of pigment to shade a patch, and direction appears. Light from this way, shadow from that. A ciliated lava turns slowly toward the brightness that promises a surface rich with oxygen and food, or away from the glare that exposes it to mouths. Navigation at this scale is not a map, but a leaning. The molecules that sense light, opsins and their cousins, were likely old even by Cambrian standards. Perhaps born in the deep time when unicellular swimmers needed to find or flee illumination. They are shapeshifters keyed to photons, tiny levers in membranes that, when nudged, start a cascade. The beauty is their reusability. A patch becomes a pit becomes a cup becomes a pinhole, and once you own a pinhole, you flirt with images, however soft. A shadow is no longer just a dimming, it is a direction and a shape. Imagine a shallow cup carved into the skin of a small bilateral animal. Light arrives from above. The rim of the cup blocks rays from the side. The bottom knows the difference. The animal moves and the shape of the brightness shifts. A crude image without edges, a smear that nevertheless tells a story. Large and near, small and far, a gradient that changes quickly means motion. For an animal that grazes the mat, a quick change is often danger, something larger passing over. Freezing for a heartbeat, or diving the head into the sediment for a breath, can be the difference between being a grazer and being the grazed. A pinhole camera, the simplest eye that makes pictures without a lens. It asks for a compromise. A smaller hole sharpens the image but dims it. A larger hole brightens but blurs. Water, even when clear, steals light greedily. The pinhole, to be useful at dawn or at depth, may want a helper. The helper arrives in proteins that clarify and concentrate. A lens begins, perhaps first as a thickening of secreted material over the opening, then as a more organized body with a gradient of refraction. Glass made of flesh. It is not far-fetched to think that proteins used for other chores, a heat-shock guardian, an enzyme from the cytosol, were recruited to pack the lens, chosen for clarity and stability, then refined by selection into crystallines. Biology often borrows its own furniture and rearranges it for new parties. Meanwhile, another path, no less elegant, explores multiplicity, the compound eye. Rather than one large cup, many small cups. Ommatidia, tiny optical modules, each with its own corneal window, crystalline cone, and set of photoreceptors, each staring at a narrow slice of the world. Together they make a mosaic of the surroundings, more like a fresco than a photograph, superb for detecting edges, motion, flicker, an early warning array. Add pigment cells between modules and you isolate their views. Increase the number and you smooth the mosaic. Curve the whole assembly around a head and you gain a near hemispherical field. In water with particles and glint, a compound eye's gift is not sharpness at distance, but honesty about change. Something moves that is enough to matter. Trilobites, those quietly charismatic citizens of the Paleozoic, carry compound eyes whose lenses are made of calcite, a mineral lens, stiff and clear, with properties that suit focus underwater. Early forms may have begun simply with tightly packed lenses under a shared corneal sheet, a holocrol eye later called. Others, later, will experiment with fewer, larger lenses set apart. Schizocrol, a word that sounds like a seashell itself. We do not need the terms tins. Feel the idea, a surface studded with windows, each a little telescope. Calcite, with its tendency to split light into two rays, seems a risky choice for optics, yet arranged just so, aligned with the crystal's axis, it behaves. The sea, once again, teaches that a risky material can be made loyal by patient geometry. Elsewhere in the Cambrian Sea, other solutions glitter, a predator of the time, an anomaly carried, large for its day, its mouth a ring of plates, its body ribboned and flexible, appears in certain deposits with eyes that hint at thousands upon thousands of facets, each facet a module, each module a pixel in a living mosaic. If even a portion of those facets were live, the field of view and the sensitivity would have been a marvel in a world that had only recently learned to look. The idea of being watched may have entered the ecosystem like a new weather pattern, subtle at first, then altering afternoons. It is tempting to declare that eyes caused an arms race, predators seeing prey, prey learning to hide, or harden, or flee, escalation spiraling into the diversity we admire. The truth is probably more braided. Vision joins other senses, chemistry, touch, pressure, soundless vibrations, and together they raise the ceiling on what behaviors can work. But it is fair to say that once images exist, even blurry ones, the room changes, camouflage begins to make sense, signaling with pattern becomes possible, posture acquires meaning beyond touch. The ocean grows social in a new dimension. Consider the simple gift of horizon, an animal that can detect the line between light and dark, can keep itself oriented, can hold depth, can surf the thin layer where food concentrates. Consider edge detection, the ability to notice a contrast that moves, a shadow passes, a reflex tightens muscle, the body tucks, the shadow passes again but slower, and curiosity wins. A palp touches, the mouth tries. Consider range. A lens focuses faintly, the blur is smaller when far, larger when near. A brainlet, hardly more than a knot of processing, can learn an association between blur size and touching time. Decisions speed up. We should stay gentle with the word brain. In many Cambrian animals, the processing center is more like a decorated hallway, ganglia in a row with a front vestibule where more wires arrive. Yet even a vestibule can do a lot if the inputs are consistent. In image-forming eyes, neighboring photoreceptors feed neighboring fibers, and that arrangement preserves a kind of map. Lateral inhibition cells whispering, "I'm bright, so you may be less so," sharpens edges. Suddenly a mottled world resolves into boundaries. The geology of the seafloor, the ripple edges, the burrow lips, the plant-like fronds becomes geometry a body can pass and navigate. Light has moods underwater, and eyes inherit them. In the surf zone, everything flickers. A compound array excels here, translating flicker into motion. In placid bays with clearer water, an animal that can form a sharper image gains a small reach, catching prey at a distance rather than only upon accidental touch. At dusk and dawn, sensitivity matters. A bigger pupil or its compound equivalent, a wider acceptance angle sings. At midday, glare can be blinding, pigments that march in and out to shield receptors, or tiny irises that narrow, keeps sensors fresh. Animals become meteorologists of light on small timescales. Where vision arrives, colors are not guaranteed to follow immediately. In water, red vanishes early. Long wavelengths seldom make good signals unless you nestle very shallow. Blue and green travel patterns of brightness, not hues, rule. Later, with pigments that absorb and reflect in clever ways, bodies will paint themselves. For now, contrast is king. Stripes that break outlines, spots that mimic the dapple of wave shadows, surfaces that mirror. Even the earliest shells, if glossy or matte, might answer to light differently, making a body stand out or blend. In sand, being seen is sometimes bad. In courtship, it is sometimes everything. To be seen, and to be the one who sees, that exchange reshapes the seabed. Grazers lift from the mat and begin to move more often in bursts, feeding in windows of lower risk. Burrowers go deeper, or else choose times of low ambient light, becoming crepuscular before the word existed. Filterers that once waved evenly now fold their fans when a large shadow dims the sun. Ambush predators learn the patience of stillness. Pursuit predators practice the timing of a strike. A soft arms race, if one likes the phrase, may have begun, not always hard parts versus hard parts, but information versus information. There's a quiet ecological feedback too. As sponges and other filterers clarify nearshore waters, vision earns returns. As grazers keep microbial films patchy, the seafloor's reflectance changes in mottled ways that eyes can use. As sediment gets stirred by burrowers, the turbidity rises after storms, favoring dialogue with smell and touch, until the water calms again. No sense rules alone, they swap rain by hour and weather. We can dwell briefly in the craft of optics. A lens made of tissue can be refined by layering proteins so that the index of refraction changes gradually, bending light without sharp boundaries. A gradient index lens. Such a lens can focus over a range without distortions that plague simple spheres. Lenses also must cope with spherical aberration and chromatic confusion, blue focusing nearer than red in many materials. In water, where blue dominates, the problem simplifies a little. In calcite lenses, alignment with the crystal axis reduces double images. All of this sounds technological, and perhaps that is the wonder. Nothing in an animal knows smell's law. Yet the bodies that stumbled closer to it saw a touch clearer and left more descendants. In this tender way, physics becomes flesh. Eyes also have maintenance chores. Photoreceptors saturate and must reset. Pigments bleach and must be rebuilt. Stray photons trigger noise, which brains must learn to ignore. Some lineages solve this with turnover. Rods of sensitivity replaced often, pigments recycled tirelessly. Others with structure, stacked membranes, cramming more receptor into a space, or microvilli arranged to gather polarization cues. Polarization, a whispery property of light in water, can reveal surfaces and tension lines invisible to brightness alone. To animals that can read it, the shimmer of scales, the line of the horizon, even the wake of a swimming neighbor, is a letter. The fossil record, kind when it chooses, has preserved some of these arrangements in astonishing detail. In a few Cambrian outcrops, under particular geochemical mercies, the microstructure of eyes appears as shadow architecture, arrays of lenses, the corrugation of ommatidial fields, the outlines of stalks. We read them like a music score with notes missing, many facets we say, therefore perhaps high acuity for motion, large lenses frontward, we murmur, perhaps a frontal zone specialized for predation, soft certainty, respectful speculation. Not every Cambrian animal needed eyes. The deep, where light dies quickly, still offered chemistries to live by. Within sediments, touch and taste suffice. Even near the surface, some bodies chose the comfort of darkness. Caves in reefs, crevices between boulders, the underrim of mats. But the presence, in the same neighborhoods of animals that could see, had effects that propagated. If you do not look, you may still react to someone else's gaze, by living as if watched. Harder shell, deeper burrow, more wary emergence. Information flows even when not read directly. There may also have been the first hints of display bodies that, whether by accident or by quiet selection, presented patterns that others of their kind responded to. bands that help a mate recognize a mate, spots that make a mother's posture meaningful to larval eyes, a raised spine that says not worth your trouble. The language would be very simple at first, a pigeon of brightness and pose. Over time, grammar enters, but even a pigeon can alter a neighborhood. If we follow one trilobite along a ripple field in our minds, we can feel the world through its optics. The mosaic is not a human image, it is a dome of little angles. A shadow moves to the right. 3 armatidia in a row grow darker in quick succession, and the animal turns left more by habit than thought. A patch of mottled light ahead suggests the edge of a frond, and the trilobite adjusts its gait to skirt it, water curling off its armor in tiny sheets. It lifts its body slightly over a hummock to sample the flow. The field of facets tilts. The sun glances the lenses and throws a brief starburst, useless perhaps, but pretty. Quiet competence, practiced in a world newly visible. We pause. After all this electricity and geometry, to breathe. The sea is a paler green now. The sun has climbed. Fish, true fish, are still pages away in our book. But swimmers exist, and crawlers and gliders on little fins. Fields of small shells, like spilled millet, glint in shoals, where waves sort them. A shadow passes, large, patient. Below it, a dozen small bodies press closer to the sediment, perhaps out of instinct, perhaps out of mere mechanics. In their tiny cup, eyes a dimness deepens. In their compound arrays a pattern stutters. Then the light returns. Then the world is ordinary again. Light has arrived. As a teacher, it does not command. It invites. It shows the room in a new vocabulary, and waits for bodies to learn the words. Those who learn faster often eat, and those who learn to hide keep the lesson going. In the chapters ahead, shells will thicken, traps will be set, burrows will spiral, and the seabed will turn from mat to labyrinth. None of these require eyes, but with eyes they accelerate, and with eyes they acquire a sheen of theatre. We, the latecomers, cannot help but admire. We will, next, feel the weight of that theatre, how bone and shell and carbonate plates entered the scene, not as a denial of softness, but as a complement, a new way to be firm in a fluid world. For now, let the last image of this chapter be simple, a pinhole of dark within a small pale cup, a photon finding a molecule changing shape and telling a neighbor, a wave of notice traveling into a body, a tiny animal, hardly more than a whisper, turning toward or away. A glance, and then a choice. Light arrives, and with it, a new kind of day. Before speed, before choreography, there is the notion of holding shape. Water is kind to softness. It carries, cushions, forgives. But water also demands a certain poise. To push against it, to lever, to bite, and not be bitten back. A body may wish for a firm edge. In the Cambrian, edges begin to appear. Mineral quietudes grown from skin and secreted from tissue, crisping the boundaries of many lives. Perhaps it starts as thrift, or as housekeeping. Calcium and phosphate drift in seawater like coins in a fountain. Cells, keeping their interiors orderly, move ions in and out. Too much calcium in the cytosol makes signals shout, hush them. Vesicles sequester the surplus. Proteins tidy it away. What if some lineage has learned to export that tidiness, to crystallize the surplus, just outside, gluing ion to ion into a lattice? What if chemistry, already practiced at knitting macromolecules, found it easier than we imagined to precipitate clarity into shape? A thin veneer forms. At first it could be patchy, nodes of firmness linked by softer membranes. Protection is already different when hardness interrupts a predator's teeth. Friction is different when a surface is no longer merely skin. The veneer thickens. Growth lines begin to appear like quiet tree rings. The body remembers seasons in mineral. The sea's mood matters. When waters are friendlier to aragonite, many shells speak that dialect. When calcite is easier, others adopt it. Phosphate writes a different script, dense, excellent for teeth and spines, and little plates that need to hold an edge. Silica has its own poetry, slow to dissolve, beautiful in needles and meshes. The tools at hand are not neutral, They invite designs. A sponge, even a quiet one, salts its body with glass spicules and becomes a fragile cathedral that no soft grazer can easily tear. A budding reef, composed partly of such architects, lifts the seafloor into relief, making nooks and shadows that new actors will learn to use. Somewhere between the last pages of the Ediacaran and the early Cambrian, we notice a scatter of tiny mysteries, a gravel of teeth and plates and shells, the small shelly fauna as later mouths will call them. There is a feeling of rummaging in a drawer of spare parts, here a hollow cone, there a little tooth beyond, a scale shaped like a roof tile, meant to overlap its neighbours. Some belong to animals we already recognize by later kinship, early mollusks perhaps, trying on forms. Others seem to come from beings we can reconstruct only in outline. Quilts of sclerites that, when assembled, make a low armoured slug, or a bristled pillow with paws, or a barbed tube anchored in mud. The aggregate impression is of many experiments running at once. Small claims staked in the landscape of hardness. Among the soft, a rumour spreads. Something tried to bite me, and the bite didn't go through. Defence is a story we tell, because it feels right, and perhaps it is partly true. After vision, after fast emotion, after the first true predators tested their arms and rings of plates, protection that is more than a reflex becomes good policy. But armor also does other work. A stiffened edge lets a muscle pull more cleanly. A firm base allows cilia to beat without trampling the skin. A shell is leverage. A purchase, a way to turn a push into a glide rather than a wrinkle. Even a small plate beneath a limb changes the mathematics of movement. Exoskeletons, in this sense, are not merely shields, they are scaffolds for behavior. Consider a trilobite again, but now from the inside out. The cuticle hardens, a protein chitin composite, laced with calcium carbonate. Segments articulate along pleural lines. A central axis carries a rhythm of muscles. On the outside, the animal seems like a quiet sled of stone. On the inside, it is a ballet of soft tissues, tugging against attachment points, hydrostatic compartments, inflating and deflating, legs fanning water, mouth parts choreographing crumbs. The shell is what allows all this to be repeatable. Push here and you move there, bend here and you tilt, lift the thoracic segments, and you enroll into a defensive curl, a consistent physics rehearsed. Yet skeleton comes with cost. Growth for an exoskeleton is stuttered. The animal must molt. For a time, hours, days, it is vulnerable, a tender thing in a world that has learned to test tenderness. Those who time their molt with the darkness or with the quiet in the current, those who hide in the lee of a stone, those who grow quickly afterward, they leave more descendants. Vulnerability can shape social rhythms long before there are schools or herds. A whispered synchrony might emerge. A neighborhood molts together when the water cools, when the moon's pull nudges tides into a certain energy, when chemical cues accumulate. In such brief truces, the sea is soft again. Endoskeletons are a different answer to the same problem. Rigidity tucked inside, with skin left pliant. In the Cambrian, hints appear of structures that later will be familiar. Simple rods of cartilage-like tissue in early chordate cousins, spacules in the bellies of echinoderms that will one day become stars and urchins. The principle is the same. Mineral and matrix converse, cells become masons, as well as neighbors. An inner frame frees the outside to specialize in sensation and exchange. An outer frame frees the inside to hold a hydrostatic pressurization. The room of possibilities enlarges either way. Between these poles, inside and outside, lives a spectrum. Some creatures embed small plates in their skin, making a mail of pebble armor beneath a velvet. Others set spines through cuticle like the quills of a thoughtful cactus. Some secrete tubes and live within them as tenants, apartment builders in the mud. Hyoliths carry conical shells with elegant lids, like tiny ice cream cones with doors. Brachiopods clamp two valves around their tender factories and anchor by a stalk, opening and closing like quiet purses. Mollusks, if we may speak broadly, experiment with coiling as a strategy, winding their shells into logarithmic shelters that grow without changing shape. A mathematical lullaby. Reefs, tentative and scattered, rise. Archaeocyths, their cups perforated and nested, dot warm shallows like a field of stone flowers. They are not corals, yet they do a coral's work, stiffening space into habitat, baffling currents so that larvae might linger, lifting platforms where other builders can settle. A reef is not only geology, it is memory made communal. As skeletonizers stack upon skeletonizers, the slope of the seafloor changes from smooth to crenulated. Predators find alleys, grazers find ledges. The shade at noon becomes as important as the light at dawn. Shells record weather. Growth lines tighten in lean seasons. Chemistry within a band reflects the water of a particular month. The ratio of oxygen isotopes frozen into a layer whispers of temperature. The whisper of strontium stands for the river's song that year. In this way, skeletons become diaries, written in a pidgin of elements. Even the scratches on a shell are sentences, grazing marks, failed strikes, the carry of sand in a storm. A storm bed itself, Kowina after a blow, reminds us that hardness becomes sediment when the sea clears its throat. Armor is eventually beach. Predation and armor do not only escalate, they invent each other's subtleties. Drillers learn to rasp a hole through a valve. By dissolving calcium locally with a bit of chemistry, shell bearers thicken their edges and complicate their layers, inserting a thin organic sheet that frustrates the drill by blunting acid or stopping a crack. Envelopes become ornamented, spines to make a crabby mouthful, ribs to stiffen, nodes to break up a predator's purchase. Ornamentation also makes hydrodynamic sense sometimes, setting boundary layers that reduce drag at certain scales, or creating micro-eddies that keep silt off a siphon. Beauty in nature is very often engineering seen from the right angle. Inside a shell bearer, the seam between life and mineral is tender. A mantle, a skirt-like layer of tissue lays down crystals in order, directing orientation with proteins that act as tiny templates. Mecha, when it later arrives in some lineages, is a miracle of patience, brick upon brick of aragonite, with organic mortar. Each layer shifted slightly, making a material that resists cracks by forcing them to turn and turn until they tire. Even in the Cambrian, simpler laminations appear, enough to show that bodies are not passive recipients of chemistry. They are composers. They do not simply precipitate, they design within their means. Where shells dominate, new biogeography follows. Whole shoals become pavements of fragments. Dunes of broken plates migrate like sleepy herds in the lee of a boulder-sized trilobite molt. Fine mud settles and preserves what would otherwise be trampled. Shell beds act as both armor and archive. They also alter the food web. Detritivores learn to sift the interstices. Microbes learn to live on carbonate. Nibbling at surfaces, borers take up residence within the skeleton itself, turning shelter into meal. In the Ediacaran, the mat was society. In the Cambrian, society begins to be a city. Walls, doors, rubble, workshops. We might wonder about the animals who remain mostly soft. Did they fade? Probably not. Many found success in the shadows of structure, in faunal lives within the sediment. Gelatinous drifting high above storms, slender threads threaded through cracks, where mineral mouths could not follow. Softness has its own economies, quick growth, flexible reproduction, sudden blooms when conditions are right. Skeletons set a new baseline, but the orchestra remains mixed. Strings, brass, woodwinds, a percussion of storms. The melody of life is fuller, not singular. There is also the matter of color and texture. Calcium carbonate can shine if polished by life, or dull if grown rough. A glossy shell may shed fouling, a matte one may vanish into the ground glass light of a sandy bottom. Patterns engraved on surfaces, ribs, ridges, pits play with light as surely as any pigment, creating shadows that to a compound eye become statements. Even before dyes become common advertisements, architecture communicates. If we wish to place a gentle marker in time, we might say that the early Cambrian fills with this mineral talk, dozens upon dozens of lineages, learning to lay down hardness in their own dialects. Some of those dialects will go quiet, others will become the dominant tongues of reefs and beaches for eons. But in this moment, variety itself is the theme. a phosphatic plate on a small tube-dwelling animal here, a calcitic bivalved house there, a siliceous net filtering in the background, a chitinous cuticle everywhere, sometimes cross-hatched with mineral like a basket plastered with stone. The reasons why our hunger for cause stay plural: predation likely pressed, oxygen likely enabled, seawater likely invited, developmental toolkits likely stood ready, ecology likely rewarded those who tried. There is also the whisper that waste became art. Ions that could be troublesome inside a cell became useful outside. Detox turned into fortitude. It is a pleasing inversion, and perhaps a true one in part. Life is good at sidestepping problems by turning them into features. Walk slowly along a Cambrian shoal in your mind. Your feet sink a little into a gravel that clinks, a music of fragments. At your toes lie the halves of a small brachiopod, the hinge still delicate. Nearby, a hyalith lid shaped like a comma. Here, a field of trilobite molts, split neatly along sutures where Odysseus once opened like a book. The tide is low. The sun finds facets in the debris and throws them back as sparks. In a pool between bars, sponges make chimneys of glass. On one, a thin film of green that will never quite become a plant, as we know it feeds quietly on light. The air smells of salt and thyme. When the ripples advance again, they will shuffle this archive, but not erase it. Skeletons let memory resist, and yet hold the soft truth. The living animal inside the shell is still a creature of breath and fluid and nerves. If a crack runs across its house, it feels the tremor in its body. If feels is not too large a word, and sets about repair, or withdraws, or flees in the awkward way a shelled thing can. A trilobite curls and trusts the seam. A mollusk tightens every muscle like a held note. A worm with tiny plates turns itself so the plates catch the bite. For all the clink and glitter we ascribe to this time, the intimacy between softness and hardness is the actual marvel, the interface where life touches its own geology and calls it home. Soon we will slide from structures to behaviors, into the sediment, where burrows lace like cursive, into moments where speed and plan meet, into a world where predation is not only a mouth but a way of thinking. But it helps before we leave to praise the patient architects, the mantles, the cuticles, the microtubules that laid down crystal planes as if they were sentences, the Cambrian learning to carry stone, the sea learning to sound a little like a city, the light catching on a ridge and making a single bright stitch on an ancient morning. Imagine crouching at that ancient waterline, eyes level with the sand. In cross-section you would see, perhaps, a thumb's width of rippled bed, a sheen of microbial film laced with grains that glint. Below, the mud darkens, as oxygen is consumed in chemistry's quiet work. Before burrowers, the redox boundary, the line where breath gives way to other metabolisms, sat close to the skin. After burrowers, small tubes irrigate the sediment, pulling oxygen deeper, carrying reduced chemicals upward, creating tiny seesaws of reaction where none had been. A single worm becomes a plumber of worlds. A community becomes a weather system for the seafloor. A finger, then a hand, then a neighborhood of hands. Bioturbation is the later word, life stirring life's own sediment, turning laminae into lace. In the early Cambrian, this stirring seems to gather itself, as if a new kind of restlessness had learned a map. Burrows lengthen, deepen, branch, the background stable, layered, a living varnish. Phrase. What had been a surface becomes a volume. What had been two-dimensional grazing acquires a third dimension and a new grammar. The floor of the sea had been a page, smooth, quilted, a script of microbial handwriting that held itself together like felt. In the Ediaca and hush, most lives kept to that page, lying upon it, grazing it, anchoring just above it, like thoughts that refused to sink. Then quietly at first the page was touched from below. What changed when stirring began in earnest? First, the background's authority loosened. Microbial carpets still existed, certainly in patches, in refuges, in new forms, but a consistent, planet-wide felt of microbes was less likely where burrowers churned. Grazers who once skimmed smooth films found mottled mosaics, patches rich and patches poor. Predators who once hunted on the surface watched dinner disappear into the earth, as if the table learned to pull its cloth away. Names can feel like spells, but the magic is in the behaviors they imply. A horizontal meander says, "I am searching across, tasting the film." A vertical shaft says, "I am dwelling in moving sand, holding my place in a restless world." A U-shaped tube says, "I sip from above and defecate below," or vice versa, a small engine of circulation. Spritons say, "The sea buried me. I lived, I climbed." The earliest traces of this mood are simple, delicate meanders that cross themselves and overlap here and there like a search pattern. Planolites, later minds might murmur for some of these simple, unlined horizontal burrows, the handwriting of a cautious grazer, Paleoficus perhaps, when the walls are reinforced, lined, as if the maker meant to live within a passage and keep it from collapsing. Anicolites and its kin, U-shaped domiciles of small architects who open both ends to the water and farmer draft, Monocriterion, a funnel above a shaft, like a tiny volcano where an animal maintained its window on the world. Diplocriterion also U-shaped, but with spritons stacked, arcs marking the animal's ratcheting escape from burial, up and up as storms laid new weight upon it, and there vertical tubes by the dozen, scolithos, straight chimneys in shifting sand, the signature of high-energy shores where creatures held fast like reeds. The inhabitants themselves became gardeners of gradients. A small bilaterian creature, call it a worm loosely. The Cambrian was generous with wormishness, could establish a home at the exact depth where oxygen faded and sulfide rose, harvesting the edge where both were available in gentle measure. Some may have carried symbionts, bacteria within that fed their host by processing chemicals the host could not use directly. Others groomed microbial films along their burrow walls, cropping a garden refreshed by their own waste. A tube with hairs at its lip caught particles on each gentle inhalation and exhalation of current suspension feeding by architecture. Second, the chemistry of the sediment's skin was rewritten. Oxygen burial increased because irrigation brought it in, and organic matter met it more efficiently. Sulfate-reducing microbes retreated a little deeper. Iron and manganese stepped into new negotiations. Nutrients regenerated from rotting meals below rose more easily to the interface where algae could use them. The mud's color shifted, less uniform, more mottled, a watercolor of browns and grays. Geologists, much later, would speak of ichnofabric, the degree to which sedimentary fabric is overprinted by traces, and would point to Cambrian rocks where laminae are blurred into living texture. Third, the seafloor's mechanics changed. A burrowed bed compacts differently. It lets water through in a new way. It resists scouring here and yields there. Ripple fields respond to storms with a slightly different chirography. Sandbars migrate along new lines, because the substrate is not a single cloth, but a quilt of tubes and cavities. In this subtle way, worms and their cousins became geomorphologists, soft engineers of flow. With stirring came the demise, gradual, patchy, perhaps inevitable, of a certain kind of preservation. Ediacaran silhouettes, so graceful, needed firm mats to record them. In a churned bed, the firmness cannot hold. Impressions are smeared by neighbors who arrive minutes later. It is not that the Ediacaran forms all vanished at once. It is that the page they preferred to write upon was being turned. We should hold this without triumph. Progress is a word that suits tools, not oceans. One mode of living gave way to another because the other made more room for itself. There were escapes written in the sand. Fugichnia is a later, elegant word for a creature's last-ditch run through sediment when suddenly buried. Vertiginous spirals, hasty verticals, contorted parabolas. A storm front, with its ferry of silt, smothers a field. 100 little towers begin to build, each a panicked elevator. Some reach daylight, some fail. Those that fail preserve the gesture of trying. In a quiet moment, millennia later, you can lay a finger on that curve and feel the animal's urgency like a warm echo. Predators learn the smell of a tube. Priapelid like hunters, stout, irreversible mouths ringed with hooks, may have probed the openings, tugging out the tenant by patience and force. A resting trilobite pressed into the mud left a rhizophagus, an oval imprint of legs and belly, then rose with a small spray when pursuit stirred it. Cruziana, longer furrows raked by those same legs in motion, traced their paths like signatures. The burrows themselves became signals: danger here, neighbor there, a vacancy or a ransacked room. The agronomic revolution. Some researchers might call it a phrase that conjures ploughs and fields. The metaphor is apt, gently. The seafloor was ploughed by animals that did not know they were farmers. The result was soil of a sort, aerated and mixed. A medium with new fertility. Where once photosynthesizers were tethered to the very top skin, now nutrients rose from below to meet them. Where once detritus lay in a blanket and fermented, now it was churned and eaten and exhaled into waters that could carry it away. The breath of the ocean altered, a little, exhaling oxygen differently, inhaling carbon differently. Tiny balances over ages, tilt climate. Different architectures thrived in different rooms. On wave-swept shores, vertical dwellers ruled. Scolithus pierced sands like flutes drilled in a bone. On quieter shelves where mud could settle, more elaborate galleries formed, branching mazes that reminded later humans of ant farms. Some were for shelter, others feeding machines. The animal grazed along its own walls in loops, then backfilled and started afresh. A conveyor belt garden, the spriton, the stacked, gently curved laminae within some U-shaped burrows, are the rice terraces of this world, recording adjustments to the bed over days or weeks. A notebook of patience. If you kneel and watch a modern beach at low tide, you will see little volcanoes, a ring and a hole, a sigh of water as a lugworm pumps. In the Cambrian, similar pumping may have begun to be ordinary. Little peristaltic pulses, up, down, up, a steadiness. Each pulse is a conversation, surface to depth, depth to surface. The mud becomes an organ tissue with circulatory logic, rhythmic and alive. Behavior on the surface responded. Grazers learned to pause at the lip of a tube and sense empty, occupied. A flicker within, predators learned to wait for an emergence like a fisherman watching a fly. Some shelly animals extended siphons, subtle straw-like organs that let them stay buried and feed in the water above, their presence betrayed only by a dimple that opened and closed like a thought. Others built little chimneys around their openings to keep sand from sliding in. Ornamented collars that looked like flowers to eyes that had arrived. The seabed became a low forest of signs and breaths. We might feel, deep in our bodies, the intuition that going underground changes who you are. In the dark, touch becomes text. Pressure gradients are letters. A jaw that functions in a tunnel must bite without a wide gape. Sensory hairs along a snout must read a burrow's own breezes. A body must brace against walls to strike. Even where eyes helped on the surface, underground they dimmed and smell took the lead. Some Cambrian predators may have learned to read the geometry of tubes. Hint of a curve suggests a U. The distance between openings tells the tenant's size. A collapse here signals panic there. The seabed became not just a place, but a story you could track with your face. This loveliness made storms both friend and foe. A burrowed bed, when smoothed by a tempest, offered a kind of reset. Tubes collapsed, new surfaces exposed, carcasses rolled, niches opened. In the weeks after, the plain would be a frontier again, colonized by rapid builders, those with quick gills, those with spare energy in their guts from a good season. Then the temporary forests would rise once more. Tubes, chimneys, tiny palisades, and the landscape would settle into a purr of small exchanges. Storm rhythms became ecological metronomes. There were failures written too. Collapsed tubes where a tenant misjudged a storm, burrow walls etched by the acid of a driller, truncated spirals when an animal ran out of energy before the daylight. These are tragedies at animal scale. At rock scale, they are variety, texture, proof that life was busy enough to air. As the seabed woke, the scale of communities thickened. Above, in the water column, drifters ate what rose. At the interface, filterers waved and caught. Within, bosset feeders and gardeners and ambushers plied their trade. Deeper still, Microbes rearranged the leftovers into elements ready to rise again. The seafloor became a stacked marketplace of metabolisms, each paying and being paid by neighbors it would never meet. The mat ground had been cooperative in another way. The mix ground, the churned, aerated bed, was cooperative through exchange rather than overlay. We should not judge. Both were elegant economies. Ecosystem engineering, another later phrase, means that the engineer does not need a blueprint to build a city. The act of living makes the room that others use. In time, certain traces became so typical of certain environments that they act as weather reports in stone. A field of Scolothos, high-energy shoreface, dense Cruziana with Russoficus, quiet subtidal with trilobites at work and at rest. A mottled fabric with simple horizontal lines, fair-weather muds grazed steadily. One can run a finger across a slab and feel the signature of a sea day. If we follow one creature, choose a small annelid-like worm with a tube, it begins its day by opening the top and sniffing the water with cilia. The smell, if a worm has a metaphor for smell, is of algae rich and fine. It extends a crown of tentacles and strokes, bringing flakes to a mouth that is more conveyor than jaw. A shadow passes, the draft changes, and the crown folds, the whole being slipping deeper, closing the door with a plug of mud. Later, in a lull, it pushes upward again, adding a ring to its chimney to clear slumped grains, a masonry of spit and silt. Its neighbor, a deposit feeder, chews a crescent out of the burrow wall, moves forward, and backfills, leaving behind a tube of fecal pellets that later hands will find and call a trace. The predator, a few centimeters off, probes a hole with a prying introvert and feels the slick tug of a body, a brief contest, and then the hole is empty. Above, a trilobite rakes. Its legs leave paired furrows. It pauses, Russoficus, and rests belly flat, eyes lifted. A day, ordinary, full. From time to time, novelty arrives. As architecture, a spiral burrow appears. Tight gyres that hint at a corkscrew habit. A wide-branching gallery suggests a division of labor. Sleep here, feed there. A double helix in cross-section makes later watchers smile at nature's sense of pattern. Whether these designs were rare experiments or common chores, we cannot be sure, but their presence says the seabed had become a canvas large enough that pattern could be play, not just survival. There is a human temptation to seek a cause, a singular trigger for this waking, but the reasons feel once more bradydox. Oxygen's press made deeper burrowing viable. Skeletons offered tools and invitations, stiff mouthparts to push grains, plates to brace. Predation pressed the shy to hide. Nutrients made gardening profitable. Currents in broad shelves made tubes efficient. Chimneys of food and waste. Old toolkits in development allowed bodies to build simple stereotypes of architecture reliably. A lined tube, a branching maze, a vertical shaft with rings of support, and the sea itself in its calm days between storms forgave the mess and let the experiments persist long enough to leave their writing. With the waking of the bed came an unanticipated gift. Resilience. A churned substrate, inoculated by many kinds of life, can recover from insult, storm, slump, influx of silt, more quickly than a too stable one. Tubes are rebuilt, galleries repopulated, microbes bloom on fresh surfaces, filterers return to their posts. The room remembers how to be itself. In this way, the Cambrian seafloor may have learned not only new behaviors, but a temperament less brittle, more adaptive. There were costs, as always. Burial events killed. Molting in a burrow went wrong sometimes. Predators adapted faster than prey by chance in a given patch, and the neighborhood emptied. Toxins from below, sulfide bursts could rise and stun a street of tenants. Their bodies rotting fed blooms above that cast shade. Ecosystems, even in their vigor, carry their own fragility like a vein. The waking was not a march. It was a dance with stumbles. At dusk in this imagined day, the low forest of tubes casts long shadows across ripple marks. Tiny vortices curl around the chimneys. In the last light, the lenses of a trilobite scatter a faint halo as it crosses from one set of furrows to another. The smell of the water, again a metaphor for us, deepens, a little more earthy as the day's production sinks. Inside the bed, oxygen fades by millimeters, tentacles withdraw, doors close, peristalsis slows. Microbes take the night shift. For now, let your palm press the idea of a burrow into your own mind. A loop, a stack of arcs, a straight tube with the faint memory of a resident on its wall. A signature that is not a skeleton, yet carries the animal's handwriting. The seabed wakes and writes back. Tomorrow, the same hands will stir the same page in new ways. Over millions of such tomorrows, the cumulative stirring will erase many delicate sentences we would have loved to read, and will write new ones we learnt to. The seabed, by waking, made a choice about memory, and perhaps this is the right moment to turn toward the neighbours whose presence may have quickened this pace. Predators may not invent burrows, but the feeling of being seen, the taste of being caught, can persuade a body to learn to disappear. In the next chapter, we will step into that sensation, escalation, speed, the quiet theatre of pursuit and evasion, and then soften, as always, with the image of a wave smoothing a beach, obliterating footprints with a kindness that is not about us. Something changes when you are being watched. Even if you have no words, a body knows. Muscles hold themselves differently. You feed in shorter bouts. You learn to listen with your skin. The Cambrian world, still hushed in many places, begins to thrum with this new feeling, an awareness that somewhere nearby, a mouth has plans. Predation did not begin in the Cambrian. Cells had been eating cells for a very long time, but here the scale and choreography shift. Eyes, in their several forms, have opened a window. Skeletons have given purchase, burrows have offered hideouts and ambush blinds. Oxygen, perhaps in gentle pulses, has lent stamina to swimmers and power to jaws. The result is not a war, exactly, more a quickening, a neighbourhood learning to move with alertness. Imagine a shallow shelf on a clear morning. The water is a pale jade. Thread-like grazers comb the microbial film. A few trilobites rake in sweeping arcs. Sponge chimneys filter like quiet lungs. The day is ordinary, until a shadow passes, not large by later standards, but assertive for this time, a ribboned swimmer, radiodont by later speech, kin to the famous Anomalocaris, turns its frontal appendages like two attentive hands. Each hand is jointed, lined with spines that taper to threat. Between them, a circular mouth, plates arranged in a ring that can flex open and shut, waits as if practicing a word. The swimmer banks, light skating along its lateral flaps, and the field tightens. We do not know exactly what such a hunter preferred. Soft-bodied prey are easy to imagine. A lobopodian inching across sand, a worm lifting a little too far from its burrow, a small arthropod caught between shelters, trilobites, armoured and numerous, were certainly part of the neighbourhood. Some bear scars that look like repairs after a bite, crescent gouges, smooth by growth. Whether the radiodont's oral cone could crush such calcite depends on species and on circumstance. Perhaps some scavenged the already cracked. Perhaps others, larger or differently built, tested harder meals. The record says, maybe, and we honour the maybe. It is enough to feel the point. Some bodies now moved with the intention to catch other bodies that were trying not to be caught. Speed, here, is relative. In water, even modest velocities require commitment. A ribboned hunter learned to undulate, passing a wave down its lateral flaps to generate thrust, riding vortices shed from its own body like stepping stones. Fins and flaps are expensive. It costs tissue to build, energy to move, and neural rhythm to coordinate. But they pay in reach, in surprise, in the ability to circle and try again. Pursuit becomes a way of feeding, not just a lucky collision. On the seafloor, faster becomes tighter, suppler. A preopuid-like worm, stout and patient, everts its mouth parts, an introvert bristling with scallids, into the entrance of a tube. The movement is rapid, a sudden bloom of hooks that feel for flesh. The tenant inside, sensing pressure and chemistry at once, recoils deeper, a small piston in mud. In the walls of its home, the burrower has left faint grooves where its body has rubbed, like the polish on a favourite step. The predator's hooks catch, drag. For a second, the tunnel becomes a tug of war. Some ends well for the hunter, some end with a spray of disturbed silt and a vacancy sign. Hunting, even here, is not always violence. An ambush is often a kind of listening. In a small depression hidden by a ripple crest, a flat arthropod waits, its antennae sensory filaments, as long as its body rid water like fingers rid braille. A faint pressure wave rhythmic, says trilobite, to a nervous system that has never heard a word. The arthropod lifts slightly, its underside legs clenching the sand, and when the wave is close enough, it lunges, a short, committed burst. The first strike misses. The second, now that the angle is known, finds soft tissue between hard segments. The strike is not a bite as much as a series of small, coordinated bites, gnatha bases along limb bases grinding, coxal spines pinning, the head's tiny mouthparts worrying at a seam. Meanwhile, the trilobite curls, a practiced geometry of defense. The predator's limbs soar against a shell and feel resistance. A pause, a reassessment. Then the hunter peels away. There are easier meals today. Defenses proliferate along with appetites. Spines, originally modest ridges, lengthen to make a mouthful awkward. Segments thicken and lock into tighter enrollments. The flare of a marginal ridge on a trilobite's head becomes a deflector, a way to resist being levered. Even small, soft animals add barbs to their skins. Hallucigenia's odd spines may be oversold as proof against all mouths. But one can imagine a novice predator learning regret with a single incautious bite. Waxy coatings, slime, secreted tubes, all are strategies that add friction to a world of mouths. Behavior answers too. A field once grazed at noon becomes a field grazed at dusk. Emergence times shift, burrows deepen by a body length, reopenings are made in side chambers, not at the main door. Filterers fold their crowns when shadow flickers. When light returns, they open, slightly angled to watch two directions at once. One can almost feel the collective learning the way a neighborhood shares patterns without ever speaking. Those who did a thing survived. Their kin inherited not wisdom but a body that finds it easier to repeat the safer thing. Over time, refuge seeking at certain hours feels innate, as if preference lived in muscle. We sometimes reach here for the phrase arms race, and it carries some truth. Offense and defense, escalating in response. But the escalation is not linear. It is seasonal, local, braided with climate and chemistry and the accidents of who lived where that year. In one basin, predators with excellent eyes push prey into darkness. In another, turbidity blunts vision and smell rules. In a third, a bloom of plankton fattens everything and predation is blunter, because bellies are full. The race is many races, run on different tracks with different weather. The smallest predators are easy to forget. Micro-pursuers in the plankton, larvae that feed on other larvae, tiny crustaceans that snag passing filaments with a flick. Their hunts are quick and silent, barely disturbing the surface glitter. Yet the sum of their work is a tide in its own right. By trimming the peaks of blooms, by moving nitrogen in their waste from one layer to another, they modulate the background upon which the larger dramas sit. Predation is not only about large mouths, it is about energy being gently diverted along many paths. Over the seafloor, a nervous system begins to invent new patterns. To chase, you need rhythm, a central pattern generator that can send waves to limbs without thinking through each joint. To pounce, you need inhibition, a willingness to hold and then release. To search, you need persistence that outlasts immediate reward. These are not thoughts. They are motor poems written by the coordination of ganglia. When we say Cambrian escalation, we also mean this. Body is acquiring the wiring to do more than react. To plan is too big a word. To prepare is closer. Chemical senses do not retire in the face of eyes. They double down. A plume of amino acids rising from a wounded animal is a letter legible at distance, drifting down current. Predators quarter the field like hounds, casting to find the edge of the plume, then running upstream along its thickening axis. Prey, in turn, leak fewer of the telltale molecules, or learn to move cross-current to break their trail, or hide in the wake of a rock where eddies scatter scent. Hydrodynamic reading, Feeling the small pressure shifts that someone else's motion makes is perhaps the Cambrian's most universal literacy. On a calm day in a shallow bay, the water is a page crisscrossed with lines of movement. To a sensitive filament, it is a newspaper. Evidence of these exchanges lies not only in bodies, but in their leavings. Coprolites, fossil droppings, contain pieces of shell and bits of plates, testimony to a diet that included the hard, bite marks on trilobites heal into odd shapes, repaired semicircles frozen midway through recovery. Some shells show drill holes, small, neat circles, though extensive drilling becomes more common later. Massed beds of trilobite molts, hundreds of individuals cast off armor together, hint at a synchronous shedding. Perhaps molting together dilutes risk. A predator across such a spread may eat well, but cannot eat all, and the survivors benefit from safety in numbers. Or perhaps currents and topography simply gathered empties into a low spot. Perhaps the sea allows several truths to lie side by side without contradiction. And what of speed? Speed is more than muscle, it is materials and geometry. A streamlined shell reduces drag. Limbs with paddle-like ends grab more water per stroke. A tail fan on a swimmer, hinged plates that open on the power stroke. Close on the recovery, makes a quick life even quicker. On land, later speed will splash dust and stride. In water, it draws lace behind the body, vortices that spin off and travel. Predators learn to read their own wakes. Turn too sharply and you broadcast intention. Glide a little and the water goes quiet, and a prey animal's receptors fall below threshold. Above a certain pace, pursuit is a negotiation with physics as much as with a fleeing meal. Some of the earliest chordate-like swimmers, small, slender, with notochords stiffening their backs and rows of muscle blocks along their flanks, may have been nibblers more than hunters, plankton pickers, rather than terror. But even nibblers, when they can hold a straight, speedy line, change the feel of a room. They arrive from elsewhere in seconds rather than minutes. They can sample a patch of water, reject it, and test another quickly. Wherever these thread-like pioneers swam, they wrote a new clause in the grammar of motion. Escalation, gently, also means learning when not to fight. A shelly grazer that senses a radiodont shadow might freeze and trust its camouflage, because running invites detection. A burrower might close its door and wait, because panic, digging releases a plume that reads like a flag. The opposite holds in other settings: run while the hunter is far, hide before it is near. These conditionals, if this then that, begin to knit themselves into habit. Habits across a population become the culture of a place without any mind to keep it. We feel tempted to choose heroes and villains, this hunter, that prey, because stories crave faces. But Cambrian predation reads more like improvisation in a crowded room. Sometimes the radiodont leaves with a mouthful, sometimes it leaves with nothing, and its own hunger sings for a while. Sometimes a trilobite's spines deter, sometimes they annoy a predator into stubbornness, and the spines become handles. Sometimes a worm with a wicked introvert spends an entire afternoon tugging and never eats. The sea is not fair or unfair, it is available. Over time, availability forgives some traits and starves others. A quieter side of escalation appears in the architectures of traps. A small tube dweller builds a funnel of grains around its opening. The funnel steepens the entrance, making it awkward for a prowler to get purchase. Another glues a ring of shell fragments to form a collar that breaks up the silhouette of the hole. A third exudes a chemical that, close by, dulls the receptors of would-be probers, local anesthesia as border wall. These are not elaborate snares, they are marginal gains. In a world that now contains eyes and speed, margins are everything. We should reserve a moment for error. Predation produces a lot of it. Misidentification, striking at floating detritus, wasted energy, chasing a fast shadow in bad light. Self-harm, pushing into a burrow and getting stuck during a pressure change. Prayer, too, bolting into open water when stillness would have been wiser. Failing to finish a repair before the next tide. The record of the Cambrian, dotted with partial meals and almost meals, is a record of practice. The ethics we carry have no place here, but there is a dignity in competence. A hunter that learns to end a pursuit quickly spares itself risk. A prey animal that hones its curl spares itself injury. Across a community, improving competence lowers gratuitous suffering, even as it leaves the hard fact that bodies feed bodies. The Cambrian did not invent this fact. It discovered new ways to live it. At twilight, the shelf looks changed by the day's intentions. Trails are sharper, the lips of burrows look freshly dressed, the low chimneys stand with a touch of pride. A trilobite with a mended bite crosses a pale streak where a radiodont passed an hour ago, its compound eyes catching a flicker where the water is still settling. It pauses, then resumes, legs whispering in paired furrows. In the distance, a ribboned predator rises toward open water where plankton thicken with evening. Everyone chooses a night policy. Some sleep, some prowl, some filter, some seal the door and dream in whatever way a small invertebrate dreams. If we step out of the scene for a breath, we can say, softly, that predation in this window of time encouraged a sharpening of edges. Not just spines and shells, but edges in behavior, quicker shifts between modes, more decisive starts and stops, a willingness to abandon a patch and cross the plane. It encouraged a sharpening of senses, not just eyes, but antennas with more receptors, tentacles that braid smell and touch, hairs that count the beat of a distant fin. It encouraged an economy of form growth lines that thicken where bites are likely, hinges that lock when pressure is applied in a certain way, legs that double as paddles for fleeing and as sieves for feeding. Escalation, then, is not just an arms race. It is a conversation that made animals more articulate. The afterglow of that conversation is everywhere in later seas. But in our chapter, we stop while it is still new, while the idea of being hunted has just begun to press itself into daily shape. We will, next, turn to all the many small wonders, to greet, in a gallery-like way, the citizens of this time, trilobites in their stony grace, lobopodians, walking on their soft stilts, priapelids, unbashful and efficient, early chordate threads, with notochords like bows in their backs. We will meet them as neighbors rather than exhibits. Each carries, within its architecture, an answer to a question the Cambrian asked. For now, let the water be calm again, just for a few breaths. The shadow that had tensed the field has moved on. In the raked light, ripple marks look like the ribs of a sleeping giant. A burrow mouth opens a little, tests the draft, and closes, somewhere under your mental feet. A worm slides a few millimeters forward and stops, unhurried, undecided, alive. A gallery opens when we slow down, not a museum with glass, but a corridor of water where each alcove is a life, set at its natural temperature. We will not rush it. We will let each creature turn once in the light of our minds, and then return it, gently, to its sea. First the trilobite, because the Cambrian seems to speak through them in a measured, stony voice. Picture a small one, palm-sized or smaller, its dorsal armor ribbed and regular, a head shield like a thoughtful brow, a thorax of hinged segments, a tail that reads like an epilogue. Beneath, hidden from the usual rock snapshot, a forest of paired legs, moves with the hush of many hands clapping under cloth. Each leg bears a branch for walking and another for breathing and fanning, so that locomotion and ventilation are woven into one gesture. The compound eyes, if this species wore them, are low domes of many lenses, each lens a little tube of clarity set in mineral. When the trilobite feeds, the bases of its legs, gnathobases, later tongues will call them, grind fine silt and crumbs toward a tiny mouth. When danger rests upon it like a shadow, it enrolls segments arcing inward so edges meet edges, and the soft underworld is sealed. The enrollment is not panic, it is a practiced shape, a geometry learned in the body's grammar. Some trilobites are spined like stars, ornament that may be signal, armor, hydrodynamics, or all three. Some are smooth as river stones, some eyes are large and look like lanterns, others are small, or absent, as if trust has been placed in touch and habit. They molt, as all who wear exoskeletons must, stepping out of themselves through seams that split like well-worn book bindings. Storms gather their cast-off pages into drifts. The living move among these papers, editing themselves. Across the plain, a creature like a tassel walks, soft stilts rising and falling. Lobopodians, perhaps cousins to later velvet worms, carry their bodies with a gentle accordion gait. Hallucigenia, the most whispered, is a slip of a thing, with pairs of spines rising like the smallest of fence posts and pairs of tiny claws gripping the substrate, with a quiet insistence. It might have grazed films, it might have browsed surfaces, it might simply have been an ambulant brush tasting the world. For years, pictures showed it upside down, spines mistakenly treated as legs, and there was a charm in that error, a reminder that the rock tells us what it can, not what we wish. Microdictyon, another lobopodian, wears netted plates along its sides like little windows or shields, each plate a perforated coin. The plates may have stiffened the body, or distracted bites, or shone with a pattern that helped neighbors recognize neighbors. Speculation is not sin when it is soft. Wywaxia slides by, armored with leaf-like scales that overlap like a roof, and petaled with 2 rows of long spines that cant outward. Is it a mollusk cousin? A leaf of a lineage we will not define cleanly? The debate is a friendly tide, and the animal does not mind our nouns. It grazes with a rasp, perhaps a ribboned mouthpart, perhaps a different tool, leaving a path in the microbial dew. Its armor glints in the light, not loudly, more like polished basalt. If a mouth tests it, the scales do their quiet work, and the body lives to rasp again. Nearby, a small tube rises from the bed and opens like a purse. Hyloth cone with a lid turns in the water. 2 spine-like helens angle from its sides, little props that may help with balance on the sediment or lift the mouth into faster flow. The lid, when lowered, seals when raised. It becomes a visor. The creature is not fast, it is resolute. Around its opening, tentacles gather food as if it were snow. The shell is elegantly simple, the lifestyle elegantly simple, the whole of it a lesson in sufficiency. A bivalved arthropod, Wapsia, or something like it, rose through the quiet, with oar-like appendages, beneath a shield that comes together like cupped hands. In some later preserved cousins, tiny eggs appear tucked beneath that shield, a hint of brooding, a tenderness in strategy, if not in feeling as we know it. Carrying eggs close means fewer lost to chance, perhaps, and more that hatch into lives that recognize the water's taste. The shield itself takes light like lacquer. When the animal pauses, it hovers, the legs fanning in a way that looks like thought. Morella, filigreed and peculiar, threads the water as if it were silk. Its head carries sweeping feathered antennae. Its body bears spined projections that look decorative to our eyes and functional to the animal's rudders. Perhaps, or flags to confuse a mouth. The creature seems to pair grace with oddity in exactly the proportion the Cambrian delights in. If it settles, it draws a faint signature in silt, a dragonfly of shallow furrows. Priapulids, unembarrassed by their frankness, push stoutly through sediment. Their introvert, an reversible feeding organ armed with circles of little hooks. Everts and inverts like a tongue that has learned origami. They inhabit tubes and halls, and collapse them, extend and rework them, occupy and abandon them as if their burrows were thoughts in draft. When a priapulid feeds in a wall, it leaves behind a worm's eye city of pellets, neatly stacked. Predation for them is both patience and suddenness. A neighbor feels a tug. A hallway is a throat for a moment. The sediment sighs, and there's a fullness in the priapulid's middle that speaks of success. They are honest animals, no pretense, all function, and the sea gives them a seat at every table. A small, spiky, domed thing, a potential echinoderm cousin in early experimentation, rests like a calcitic seed. The plates that compose it knit into a pattern we later will recognize in stars and urchins. But here the symmetry is still trying on coats. Some of these little beings may have attached by a stem. Some may have crept awkwardly. Some may have filtered with a comb of arms not yet what arms will be. Their ossicles, microplates, glitter under certain preservational mercies, and we lean close because within their arrangement lies a preview of a style of architecture that will one day spike our feet at the beach. A chordate breathes by swimming. Picaia thin, leaf-like, with a notochord down its back like a drawn bow, wiggles in small waves. Mylocuminia and Hyca. Names like musical phrases are threads with heads and maybe gill pouches, shadow hints of early vertebrate plans. Their muscles are in blocks, chevrons along a narrow flank. Their tails are not tassels but tools. They may have picked at suspended food, or nipped tiny animals, or simply gulped the right water, extracting and exhaling like living bellows. In them is a steadying rod, not bone, not yet. A preference for a forward sense, a stamina that turns the ocean into corridors rather than ponds. We linger here softly, because our own spine is an echo of this bow. Opobinia swims through, a being so benevolent in our imaginations that it has become a mascot for how strange can be gentle. 5 stalked eyes rise like periscopes from a small head shield. From beneath that shield a long, jointed proboscis extends, ending in a claw that can grasp and deliver. The body, ribboned with flaps, undulates. The tail fringes trail. Is it hunting small, soft prey among fronds, plucking morsels from silt? The 5 eyes are not flamboyance, they are coverage. The proboscis is not whimsy, it is reach. Opobinia reads as improbable until you imagine the problem it is solving. See widely, feed precisely, swim steadily, then it reads as necessary. A radiodont kind to a Nomolocaris, though not necessarily that very figure, passes again, this time with frontal appendages spread like open hands. On each spine-laden podomere, hooks tilt inward, as if cupped around a phantom. Along its sides the flaps scull along its back. A series of keels may help with stability like the ridges on a leaf. If it turns toward our imagined viewer, the mouth blinks, a ring of plates opening and closing with a precise menace that may be more rasp than crush, more suction than bite. We stay respectful. The animal is busy. Sponges lace the background, patient architects with filters instead of faces. Some build simple tubes of silica spicules, set in collagen. Others weave denser meshes, making skylines in miniature. Water passes through them in a whisper. Bacteria vanish into their tissues and reappear as energy measured in breath and growth. On their flanks films assemble, microbial micro-cities that later will evolve into complex alliances. For now they are simply neighbors. Sponges do not move much, but they move much through themselves and the room changes because of it. Brachiopods, those quiet purse shells clamp and unclamp valves that look like clams to a hurried glance, but speak a different grammar. Inside, a lophophore, a delicate, ciliated loop or coil, catches particles and delivers them in conveyor rhythm to a guarded mouth. Some sit on stalks, some nestle, some tilt slightly into the current, the way a face might angle toward a breeze. The growth lines on their shells curve gracefully, and to trace them with a fingertip, in imagination, is to run time forward and back across a life that preferred steadiness. Halkyrids glide, perhaps, long, slug-like, with a coat of hundreds of tiny overlapping plates, sclites, and cones at both ends that read to us like bookends. Are they bridges between mollusks and brachiopods? Are they branches gone quiet? The answer changes with new work, and our tone stays gentle. We can say that they wore their mineral with composure, and that their gait was probably a disciplined ripple, and that a mouth might have rasped a path under their low armored arc. Their sclerites fall apart into confetti when they die. Rocks keep their parties as gravel. Brodoriids, small bivalved arthropods, pepper some beds like punctuation. They were probably abundant, quick in life and timid in preservation, which is to say most of them went unremembered. But now and then a shell closes over their final pose and records 2 valves like quotation marks around a secret. To a predator they were snacks that fought by being difficult to grasp. To the sea they were converters of small things into slightly larger things, which then became slightly larger things. Tiny cones stud the plain, early mollusks that have not yet chosen coils, or have, and we simply do not see it here. Some are cap-like monoplacopherian moods. Some are long and perfect, towers for the sake of towers. Their interiors are smooth as if polished from within by the body that lived the house. When a wave knocks them together, they click. The sound is not ours to hear, but it exists. A worm draws itself through a spiral burrow and becomes a helix in stone. Another scribbles a network and lives within it, like a gardener learned in roots. The ichnofossils' traces multiply, as if the floor were a chalkboard that every morning is washed and written again. Russophaicus, the trilobite rest, Cruziana, its brushy trackways, Monocriterion, the funnel above the shaft, Diplocriterion, the U with its terrace steps, Planolites, the simple line. These names are little spells for behaviors, and each spell conjures a citizen. You do not need the bodies to love the city. You can love it from its calligraphy. In certain sheltered corners, archaeocyaths, a chorus of cup-shaped sieve-walled builders, make the Cambrian's first reefs. They are not alone. Sponges join, and the combined architecture lifts the seafloor into hummocks and walls, baffling currents, and making courtyards of light. In those courtyards, larvae pause and settle. In those shadows, predators ambush and are ambushed. In that complexity, a new dimension of living unfurls. Reefs are not just structures. They are verbs that say stay. We should leave space for the tiny and the quiet. The planktonic realm, still a thin film in our tale, hums with small crustaceans, embryonic forms, larvae of groups that will later build shells and legs and limbs. Many live a two-stage life, floating and tasting light, until a cue scent of a substrate, pressure of a certain depth, a chemical that means home, invites them to settle and rewrite their bodies. That rewriting metamorphosis is a magic the Cambrian carries already. It allows a lineage to be two things, with one genome, to travel as a seed and farm as a tree. In the gentle surf that trick spreads quietly because it works, a short walk in mind from the reef. A strange, shielded swimmer, herdia or akin, wears a frontal carapace like a visor, its mouth a familiar ring, its hands spined and precise. It is as if radiodonts had decided to accessorize with brims. The function might be hydrodynamics, might be protection, might be the result of a developmental note struck a little differently. The Cambrian tolerates such flourishes. If they pay, they persist. Not every wonder is sharpened or plated. Some are tapestries of cilia, some are sacks with excellent timing. A simple bilaterian grazer, no eyes to speak of, just a pigment cup here and there, threads between sclerite fields, with the patience of a person threading a crowded market. Its senses tell it where hydrogen sulfide rises too strong, where oxygen tastes sweet, where a film is new. It avoids the hot breath of a priapulid's burrow, with millimeter grace. It reproduces often. Its children are clouds you would not know to name, unless you knew to look. The beauty, after a few rooms of this gallery, is not a single creature, but the accumulation. You begin to sense how each small architecture solves a local problem. You begin to see neighborhoods tubes around a Hylots hill, malt fields where trilobites favored resting, spicule gardens where sponges seeded sand. You begin perhaps to relax into the idea that the Cambrian explosion is a mosaic of modest sufficiencies, any one of which considered alone is not a bang, but together they sound like surf. We carry a last handful of faces before we turn the page. A small stalked animal flexes a crown of arms and sifts. A slug-like traveller shines with a new band of shell along its back. A bristled crawler turns and shows a mouth that is more smile than more. Above them, water knits a net of light on the sand. In the distance, a ribboned predator is only a rumour, a suggestion of motion in the green. The day is mid, activity is even, the world is busy in a way that feels steady. Later chapters will ask where these bodies are remembered best. Those miraculous sites where mud kept soft things safe. We will linger at Burgess and Chengjiang and Sirius Passet and hear the taphonomic luck in their particular silts. But for now it is enough to have met a few citizens with no museum wall between us. It is enough to admit that every small wonder we love was an ordinary day to Tissace, and that our awe is a kind of weather the past does not know. Let the gallery close with humility. We step back from the trilobites' practiced curl, from the tassel steps of lobopodians, from the frank industry of priapulids, from the chiffon slither of early chordates. The room dims. The sea, outside our attention, continues. Some rooms keep secrets, others keep silhouettes. In the Cambrian, memory pulled in certain places the way fog pulls in hollows at dawn. Fine mud settled there like dust on velvet. Storms arrived like librarians, shutting the book for a moment with a firm hand, and when the book reopened, a page had been saved. Geologists have a word for such keepsakes, Lagerstätten, treasure beds, where the ordinary amnesia of geology pauses. Most rocks remember the hard things, teeth, spines, shells. These special beds remember the soft gills like lace, eyes like beaded domes, bellies with gut strings still visible as faint threads. They are not the world, they are windows. And yet, through a handful of windows a landscape feels visible. Let us walk, gently, to 3 such rooms, knowing they are partial and local and miraculous. We begin high in the mountains, under a sky that is all sky. The rock is dark, thin-bedded, stacked like 1,000 careful pages. This is the Burgess Shale, a middle Cambrian memory tucked into the Canadian Rockies. Once the place was underwater, an outer shelf near a submarine cliff. Along that cliff, an escarpment of carbonate slumps and mud flows would, from time to time, peel away and rush downslope, burying the life below in a hush of fine clay. The animals did not plan for that. They were busy living, but when the pulse of mud arrived, it pressed them to sleep, and laid a blanket with such delicacy that muscles and antennae and even the outline of a gut could be remembered as films of carbon, as shadows within shale, under a hand lens. Burgess fossils often read like ink drawings, charcoal silhouettes, softly bordered. The preservation is a kind of compression, bodies flattened, their 3-dimensional gossip turned into twinned whispers on a plane. In places, clay minerals grew along tissues, fixing outlines before decay could smear them. In others, the carbon itself persisted as a thin sheen, a sketched self-portrait left behind by chemistry. Oxygen, scarce in the burial layer, kept scavengers at bay and slowed the enzymes that prefer to eat. Biotubation burrowing was modest enough here that pages lay unruffled. The result feels like an archive curated by a patient tide. Burgess is not a single day. It is a habit in a place, pulses of burial across a stretch of time that to us is short, but to animals was many lifetimes. Each pulse fixed a neighborhood as it was, and those neighborhoods stacked give us the illusion of community. A Pabinia looks up with its 5-eyed charm. Morella holds its feathery antennae just so. Trilobites rest like commas. A radiodont's appendage lies splayed like a hand that forgot to close. We should remind ourselves, softly, that each slab is a still frame pulled from a moving scene. The animals did not line up in a parade. We arranged them that way later, because our eyes, like galleries. If we listen under the mountain wind, we might hear another voice. The voice of the sea's chemistry. Fine clay settles in quiet water. Quiet water favors oxygen-poor bottoms when the productivity above is high. Oxygen-poor bottoms favor the survival of soft clues. The Burgess Shale thus tells 2 stories at once, a story of animals and a story of mud. The elegance of the first depends on the patience of the second. We walk on, many heartbeats south and east, to a lake in the hills of Yunnan. Though the water we seek is not the lakes, but the sea that once lay beneath these hills. The Moshanshan shales near Chengjiang keep memories older than Burgess. Early Cambrian, a dawn not long after dawn, the rock here weathers to a warm brown. The fossils are delicate and sometimes astonishingly crisp. Whole communities, seemingly interrupted mid-gesture, lie in the stone, priapelids, with introverts everted like a gasp. Tiny arthropods, with filigreed limbs, cordate threads, with traces of muscle blocks, visible, eyes whose facets can be counted like rivets. How did this room remember so much? Perhaps, as with Burgess, burial was quick, storm-lane mud draping a plain with a suddenness that living things could not avoid. Perhaps, the water just above the bottom was low in oxygen, discouraging decomposers and protecting shapes long enough for mineral coats to form. Thin films of aluminosilicates tracing tissue, pyrite nucleating in places where sulfur cycling met decay. Biotubation seems to have been minimal through the most generous beds. The page stayed smooth. Notes were not smudged by neighbors tunneling for their breakfasts. Some layers feel almost like photographs of a quiet catastrophe. No horror, just the physics of particles settling. The biology of us. Chengjiang speaks a different dialect of memory than Burgess. The shales are finer in places, the chemistry a little different, the fauna in part because of age, in part because of geography, its own neighborhood. There are familiar faces, radiodonts in varieties that feel new again, lobopodians with armors that look like jewelry, sponges in a lacework that seems too elaborate for accident. There are also faces that would have surprised those who knew only Burgess. A diversity of early vertebrate-like forms, for instance, with bodies so slight you expect them to blow away. That they did not is the miracle. That they are biased toward places and times like this is the lesson. The world was richer than its ordinary rocks let on, only special rooms let us see. We go further north, and older in mood, to a place whose name feels like frost on the tongue. Sirius Passet, in northern Greenland. Here wind speaks most days, and the ground underfoot is a colour the sky can envy. The Buan Formation, which holds the fossils, whispers of a cold shelf at a high latitude in the early Cambrian. The animals are familiar and not trilobites, bradoriids, hulkeriids, radiodonts, with their own designs, creatures that look like sketches for later echinoderms, spined friends with names that carry Greenland sound. The preservation is quieter than in Burgess or Chengjiang, soft tissues show often, but as shyer ghosts, yet the assemblage is a lantern, and it lights a different corner of the sea, a place where day length and temperature and currents would have had their own cadence, their own challenges to write into bodies. Sirius Passet reminds us that Burgess and Chengjiang are not templates. They are accents. Preservation is a local craft. In Greenland's story, bottom waters may have been persistently low in oxygen, perhaps because cold, fresh surface layers cap denser brines, perhaps because circulation drew breath away, perhaps because productivity waxed without enough mixing to bring air back down. In that dimness, things laid down by storms lay undisturbed long enough to keep their outlines. The record is like a candle held behind a leaf veins clear, edges soft. We lean in, we smile. From these 3 rooms, a few more doors open if we're willing to look. Emu Bay on Kangaroo Island, South Australia, keeps its own Cambrian film. Radiodonts with eyes whose facets can be counted even now. Trilobites with spines like careful hedges, fragments that feel like scraps of a good meal. Austen-type deposits in Sweden. A little later in the Cambrian, preserve tiny animals in 3 dimensions by phosphatizing them. Larvae, minute crustaceans, the small architecture of the plankton caught in miniature, as if in sugar. Kaili, in China. Guanshan, not far from Chengjiang. Each adds a chord, a hint that the ocean's music varied with basin and season. Why here and not there? Why memory in one valley and forgetfulness in the next? The conditions that make a Lagerstätte are fussy and many. Rapid burial, fine grain size, low oxygen at the seafloor coupled with some oxygen above, mineral ingredients ready to coat a body quickly, iron and sulfur and phosphorus and aluminum, all in a mood to cooperate. Quiet after the event, so that burrowers do not plough the page. A Goldilocks chemistry that allows clays or phosphate or sulfides to stabilize outlines before bacteria erase them. Even the softness of the animal matters. Some tissues take a mineral jacket better than others. A film of mucus might speed or slow decay. A cuticle might template a mineral in a way that flesh alone would not. Taphonomy, the study of how things become stone, is as intricate as any ecology. We should also welcome bias as a teacher. Where preservation is excellent, we see many soft-bodied forms. Where it is poor, we see mostly the armoured. It can feel then as if the Cambrian's oddities are clustered in a few magical places, and the rest was shells. That is a trick of memory. The shells simply write themselves into ordinary rock more often. The soft bodies were likely everywhere too, in their appropriate concentrations. They just did not often convince the mud to keep their names. The explosion we prize may be partly the explosion of windows. When windows open wide and often, a fame is born. When they seldom open, the world looks conservative. If we could gather all the rooms together, Burgess, Chengjiang, Sirius Passet, Emu Bay, Kaili, the many less famous quarries where a slab or 2 surprises, we would see less a set of exclamation points and more a continuous paragraph. But we do not have that paragraph. We have laminated shouts. Even within a single room, Choices are made by chance. A current turns a body. The left side is preserved, the right forgotten. A gut, rich in phosphate, templates a beautiful ribbon. A gill, more fragile, fades to suggestion. A molt is fresher than a carcass. And so lies perfect. The carcass, heavier with the biology of happening, rots unevenly before the burial and becomes a skewed map. A fossil is thus two stories, the animal it was and the process that etched it. When we look, we hold both, the biography and the epilogue. There is a comfort in the craft. The people who read these pages do so with tenderness. They split shale with blades and breath, the way one might open an old letter. They whisper when a lineation looks promising, because a whisper feels right. They draw what they see and what they are not sure they see, labeling doubt almost as carefully as certainty. It is a culture, quiet, careful, generous, handed down like a recipe that is more ritual than list. You can feel the humility in the field notes. Possible gills, eyes, maybe, appendage spines, count uncertain. The Cambrian has trained its readers to be kind to maybes. Stand for a moment at the Burgess Quarry at dusk, in imagination. The air cools quickly when the sun drops behind peaks. The slabs are grey in the shadow, but if you tilt them, they wink. Mica, a fossil's carbon, a vein that caught the last light. Chengjiang at dawn is the opposite. Soft glare, a damp warmth around the hands. Dragonflies that belong to another era, tracing the present above a past sea. Sirius Passet as a wind that tests your willingness to pay attention. The cold is honest, and so are the rocks. In all three, the people who visit carry away not just specimens but a way of breathing. Slower, attentive, willing to wait for a thin line to declare itself. The rhythm suits our series. There is also an ecological lesson wrapped in this history of memory, where bottoms go quiet, by chemistry or by depth, or by lack of burrowers. Delicate things can persist long enough to be remembered. Where beds are stirred often, the living are busy, but the record is faint. The Cambrian saw a shift from firm, mat-bound surfaces to churned, aerated mix grounds. That shift is part of why the Ediaca and silhouettes fade. It is also part of why we see so much stirring, so many feedings traced out like calligraphy in mud. Memory is not lost. It changes mediums. In one room, life writes with bodies, in another with behavior. We have to be bilingual to hear both. We leave the rooms with gratitude and also with a pledge, not to overread them. Burgess is middling in time. Chengjiang earlier, Sirius Passet earlier still. But none alone can tell us the Cambrian's tempo. A lull in one basin may be a bloom in another. A predator that is lordly in one valley may be an also ran elsewhere. A lineage that seems to appear suddenly in one window may have been common just outside the frame. Our confidence must be feathered, strong enough to hold a shape, soft enough to bend when a new slab opens. And yet, allow yourself the small joy of a fossil's honesty. A trilobite's eye, made of crystal, looking back across 500 million years. A worm's resting pose, a gut with lunch in place. A bivalved arthropod hugging its eggs beneath a shield. A sponge's chimney with the geometry of a patient mind. These are not metaphors. They are facts preserved by chance and read by care. We respond to them because they feel like voices, even if the animals did not mean to speak. If places that remember have a moral, it might be this: the world is always fuller than its ordinary traces. Once in a while, the conditions align and fullness is visible. Most days life is busy, and the mud is indifferent. In the Cambrian, as now, the miracle is not the few remembered places. It is the constant presence of lives that never asked to be remembered, and lived completely anyway. Let the doors close. The rooms are not gone, they wait in stone. We walk back out into the general ocean of our story, able now to imagine specific faces, where before there were only words like radiodont and lobopodian. In the next step we'll listen to how these fossils keep secrets even when they seem to shout. How a film of carbon, a trace of pyrite, the bend of a clay platelet, can be a whisper that takes years to hear. We will keep the volume low and the illusions in check. For tonight, one last look: a slab on a palm, a black leaf of shale, a faint animal drawn upon it, like a careful sigh. You tilt the light follows the curve of a limb. A pattern becomes certain. The past nods. Stones do not speak. They persist. And yet, if you learn their pauses, their habit of keeping pressure and shadow, they begin to offer clues. Small, consistent hints that together feel like words. The Cambrian comes to us not as a voice, but as a palimpsest of gestures in mineral films, molds, sutures, scratches, halos, each the residue of a body meeting mud, then time. Taphonomy is the quiet craft here, the study of how life becomes record. It asks gentle questions. What was a body when it met the seafloor? How fast did the blanket of sediment fall? Which minerals volunteered first to hold a shape? How much were the pages stirred before the ink dried? Each answer is a tilt rather than a verdict. Each tilt guides a hand that draws. Begin with the simplest miracle, a carbon film. A soft animal dies, or molts, or is suddenly swaddled by a pulse of clay. Oxygen is shy at the bottom. Bacteria begin their careful work of unmaking, but the burial is quick enough, fine enough, that outlines hold. Organic matter slims down into kerogen, a residue of carbon that behaves like coal in miniature, thin, lustrous, stubborn. Later, when we split shale along its delicate planes, a black silhouette gleams and the past looks back like ink. The film is not the whole animal. It is a letter, written with the thickest strokes. Appendages can be read, sometimes guts, sometimes gills, but depth is lost. We receive a shadow with a personality. Sometimes clay does more than blanket. It collaborates. Iron by iron, aluminosilicate minerals precipitate along tissues, guided by the chemistry of a decaying surface. Bacterial coats, charged membranes, subtle exudates that template a veneer. The result is a Burgess shale-type whisper, where even fine frills can appear as varying shades and sheen. The clay platelets, aligned like cards, reinforce detail before the gentle chaos of decay can erase it. We call it replication. But that sounds too mechanical. It is more like an impression taken by a patient hand. Elsewhere, sulfur joins the scene, in pores where oxygen has been spent. Sulfate-reducing microbes breathe their version of breath and make sulfide. Iron is ready, and pyrite falls gold, nucleates as tiny framboids, spheres of spheres. If this precipitation hugs a gill filament, a gut wrap, a cuticle seam, a three-dimensional lace is preserved in iron sulfide. Later the pyrite may weather, trading its gold for oxides, the detail softening, the edges rusting. In the fresh cut though, a gleam reveals filigree, a memory cast in glitter. We learn the caution too. Pyrite expands as it alters. Collections must breathe. Specimens must be treated kindly. The clue itself can be lost by carelessness, long after time did its part. Phosphate can be a gentler guardian. In some settings, phosphatization happens almost indecently fast. Hours to days, wrapping minute bodies with a mineral jacket that keeps their volume. Microscopic larvae, delicate limbs, tiny mouthparts accrue appetite like frost, and an Austen-like deposit is born. A cabinet of miniatures in 3 dimensions, animals so small you cradle them with light instead of tweezers. Acid etches the matrix away in the lab. The creatures emerge like ivory carvings. You can turn them and see under jaws between plates, into socket and joint. It feels like cheating, but it is just chemistry happening before total loss. Shells, harder from the start, leave different notes. Calcite can persist through much, recrystallizing, annealing, sometimes dissolving and leaving a mold that later cements fill. Aragonite is more fragile. Often it vanishes. Its space kept as a cavity, a negative, where once there was sheen. Phosphate is dense and secretive, keeping fine texture if left in peace. Silica is a stubborn friend, but also prone to ghosting. Spacule forests blur as pressures shift. Each mineral has its temperament, and a preparator learns to read moods. This layer will flake. This will take a polish. This will survive a brief bath in acid. This will not. Between body and bed lies a whole theatre of behaviour. Traces ichnofossils are the calligraphy of movement made sediment. They are not the animal. They are its wake in time, a pair of parallel grooves marching across a slab. Cruziana says a trilobite raked here, legs brushing like combs, an oval with faint cross hatches. Rossoficus says it rested here, belly down for a while. A simple tubing cross-section, Planolites, says someone fed or travelled this way, unsafely shallow or safely deep, depending on context. U-shaped domiciles. Anecolites, Diplocratarian, announce an architect who preferred 2 doors to 1. Sprytons stacked like terraces, record escape from burial, each layer a choice. Even the very first hesitant Cambrian burrow, the trepticnus-like probing with its repeating offset forks, reads like a nervous system learning to map a 3-dimensional room. You can run a fingertip along a meander and feel a decision made in sand. Traces come as reliefs, raised on a bed's underside, because an infill resisted erosion, or pressed as grooves where the maker ploughed. Positive hyperrelief, negative epirelief. Poetry disguised as jargon. A single bed can carry a palimpsest of mornings and evenings if the sea was gentle and hungry hands were many. Time averaging blurs, we read it with humility. Humility is the taphonomist's first tool. Compaction flattens. A shrimp-like creature becomes a calligraphized ribbon. Organs trade places in the squeeze. A mouth that looks central may have been ventral and simply displaced. Delicate structures vanish first. Their absence is not proof of absence. Dead assemblages mix with life assemblages. Storm beds gather molts and corpses that never met. A slab that feels like a community might be a collage of days, even of years, curated by currents rather than by any living plan. So we triangulate. We compare duplicates from other beds. We peer under different lights, raking light to catch relief, polarized light to find sheen, low-angle sun to make microtopography speak. We wet the surface and let water give a temporary gloss to indeterminate patches. Sometimes a hidden limb lifts like a bruise. We bring instruments, quietly microscopes that let us walk across a specimen like a city. Micro-CT that X-rays volume where our fingers cannot go. Beams of high energy that coax trace elements to reveal where tissues once lay, chemically distinct from matrix. These are bright tools, but our tone remains dimmed. Technology can resolve, but it cannot guarantee interpretation. There are artifacts, things that look like biology and are not. A crack masquerades as a limb. A mineral fiber suggests an antenna. A fold in a film pretends to be a gill. Preparation itself can invent lines. An eager needle following a wish rather than a feature. The remedy is community, 2 pairs of eyes, 3, 10, contradicting gently, teaching one another what to see. In notebooks, small words, possible, likely, uncertain, decorate sketches like leaves. The Cambrian has taught its students to cultivate doubt as a form of respect. Now and then, stone confides secrets more intimate than we expected. A gut with contents tells of diet, not a speculation but a mouthful frozen at noon. A ring of eggs tucked beneath a bivalved shield hints at brooding. Not sentiment, just strategy. A base serration carries polish from life use. Not preparation, wear facets that say a mouth ground fine food every day. Growth lines on shells. Sclerochronology's sheet music. Tighten with stress, loosen with plenty. Isotopes within them whisper of temperature and water mass, of seasons that meant little to the animal's language, and everything to its metabolism. Eyes lend their own physics. In trilobites, calcite lenses hold crystal orientations that tell of optical correction, not accident. The stone does not intend to reveal, it simply retains, and we choose to listen. Concretions, the small worlds where chemistry wrapped a nucleus quickly in carbonate or phosphate or iron, are time capsules of their own type. The carcass, rich in reactive molecules, becomes a seed. The cement grows outward, encasing a tiny radius of life in an early shell that resists later pressures. Split such a concretion and the interior can read like a fresh crime scene, tissues in relief, voids uncrushed, even the faintest of skins intact where the surrounding mud has been mashed. Concretions can mislead. What is preserved can seem normative, but they can also rescue. In them, compaction's flattening hand is held back long enough for us to meet a body almost as it was. Then there is the long eraser of diagenesis, those changes that accompany burial and then uplift. Minerals trade places, fluids percolate, the very fabric of a rock shifts at the scale of grains. A shell's aragonite dissolves, and a new calcite grows in its mold. What was once a crisp commissiere becomes a blurred line. A pyrite framboid oxidizes and becomes a rusty bloom. A clay template is replaced by silica, hard to prepare, harder to read. Time's second hand is patient. Sometimes the final image we hold is as much diagenetic portrait as fossil. Again, humility. Every specimen is a collaboration between a body and the earth that kept it. Bias lives everywhere in this work. Environments prone to quiet, fine-grained deposition with low oxygen preserve soft bodies. Energetic sands record steps and dwellings. Reefs celebrate builders and those who lived near them. Deep basins, anoxic and still, hoard delicate drift and starve traces. Our sense of who was there is entangled with who was preservable. Thin-shelled, non-mineralized animals were likely abundant. Ordinary rocks simply did not keep their names. We hold the Cambrian as a riot of hard new architectures, because the rocks are loud about hardness. The soft riot requires special rooms. We keep both truths in view. Reconstruction then is an art as much as a science. An illustrator takes a flattened body and restores volume, chooses an angle for a mouth where the mouth is uncertainty, selects a color for a carapace. The rock cannot tell color, except in rare later cases when melanosomes give suspicion of shade, remains a dream. Behavior is often analogized from form. This limb looks for raking, that proboscis for picking, but analogies can seduce. We say perhaps, we say seems, and these words are not weakness. They are rails that keep the train on the track. And yet, even with rails and caution tape, joy threads through the reading. Imagine splitting a shale and seeing, on both faces, the mirror images of a creature part here, part there, because the parting plane passed right through its body. You align the halves, a little world recombines, or lifting a thin slab and finding on its underside the raised relief of a trace you did not know was there. Positive hyperrelief whispering from the dark, or dissolving a chip of limestone and swirling the residue in a dish until a microanimal settles in the meniscus like a tiny toy. And suddenly there is a face where before there was dust. These small encounters feel like a private correspondence with time. We can also read absences carefully. In the earliest Cambrian beds, with heavy burrowing, the lack of Ediacaran-style impressions is not proof that such bodies never lived nearby. It is proof that their preferred medium for memory, firm mats, had been erased by stirring. In storm-dominated sands, the scarcity of minute soft bodies says little about their real numbers. It says the book was being slammed shut too often for whispering ink to dry. Where we see an explosion, some part of the brightness is resolution, soft rooms opening, and old forms being forgotten because the page changed. The story is still a brightening, but we honor the room as much as the actors. Conservation Lagerstätten and concentration Lagerstätten, two flavors of rememberers. The first keeps exceptional quality, soft tissues, moments. The second heaps numbers, bone beds, shell pavements, malt fields. Both have their boasts, both their blind spots. A pavement says abundance, but also says transport, winnowing currents that played editor. A single exquisite shrimp says anatomy, not ecology. Put them together, and the moire pattern begins to look like a scene. In the end, clues in stone ask for a way of seeing that sits well with sleep. It is slow, attentive, unwilling to force. It forgives its own mistakes and amends them openly. It draws in pencil first, inks only when the hand feels deservedly steady. It bathes specimens in light and shadow, in water and air, in ideas from today and tomorrow, and listens for what survives each bath. It is in its patience, akin to the animals it studies. Small gestures repeated, gains incremental, the reward the continuation of the work. We step back from the bench, dusting the mind's hands. Outside, a night sea hums. Each wave writes its own thin line of foam and pulls it back, composing and erasing like taphonomy in fast motion. The air smells a little like stone when it cools. Somewhere on a shelf under that dark mud settles. A body meets it. A page turns. A clue is set. Not for us, not for anyone, but because that is what happens when matter and time share a bed. In the next chapter, we will listen to clocks inside bodies, to molecular whispers that offer alternate timelines, to genetic toolkits that say the fuse was long even if the flare looked bright. We will place those whispers beside the rock's voice and let them argue kindly. For now, let the clues rest where they are. The book is not closed, it is only heavy. Rocks keep time with layers. Bodies keep time with little changes. Somewhere in a quiet lab, a sequencer hums, the soft purr of a machine reading letters it cannot pronounce. In a freezer, boxes hold fragments of life script. In a screen's blue light, alignments stretch like woven cloth. Here, deep time is measured not in beds of silt, but in substitutions. Tiny switches in DNA and protein that accumulate at rates that might be, in the simplest telling, regular enough to be a clock. Regular enough is a phrase with a long inhale. The molecular clock, in its first dream, imagined that mutations, most of them neutral, some of them nearly so, would accrue at a roughly constant tempo. Count the differences between lineages, divide by a rate, add a calibration or two for scale, and an age appears. But life, generous and mischievous, writes in many hands. Rates vary with generation time, with metabolic tempo, with how vigilant selection is in a corridor of the genome, with population size and the chance that drift will carry a silent change to fixation. A clock still ticks, but it needs patient listening, and it needs the rocks to set the hour hand. When clocks agree with stone, we exhale. When they do not, we practice a different breath, one that welcomes mismatch as information. In the Cambrian neighborhood, the mismatch has long been gentle, yet provocative. Genes whisper that many divisions among animal lineages predate the first bright fossils by tens of millions of years, perhaps longer. Fossils reply, with a firm, kind voice, that the surge of visible forms is still special, even if the fuse ran long. Imagine two lanterns on a beach at night, one behind you, one far ahead. Their beams cross in front of you and make a brighter patch on the sand. The Cambrian explosion, as the rock remembers it, is that bright patch. The molecular view says, the lantern behind you had already been lit for a while. The one ahead will keep shining. Parallax is not deception, it is perspective. What, gently, do the genes say? That the basic branches of the animal tree, conidarians and catenifers, sponges and bilaterians, likely pulled away from one another before the Cambrian dawn, in the Ediacaran perhaps deep, that within bilaterians, the great cohorts exozones, with their molts lophotrochozones, with their spirals and ribbons, deuterostomes with their quiet destiny, toward chords and stars, may also trace their first faint separations into that twilight, that the toolkit for complex bodies, intriguing families like Hox and Parahox, Want and BMP, Notch and Delta, Hedgehog and Friends, was already playing motifs in simpler ensembles. The score existed before the orchestra grew loud. We do not need certainty to be moved by the shape of that claim. A small, flat grazer in the late Ediacaran, carrying in its cells a suite of genes that, when copied and tuned, could later sketch a head, a limb, a looping gut, may have lived an ordinary life under the same moon that shone on the quilted fronds. Nothing in its day would have suggested fanfare. Yet the grammar was there. The Cambrian, then, reads as a period when grammars were printed in large type. Molecular estimates arrive by many routes. Some count amino acid changes in proteins that seem to evolve slowly and steadily. Collagen motifs, for example, or ribosomal pieces that work like clockwork. Some rely on whole sets of genes, thousands at once, letting the law of large numbers smooth the noise. Some focus on microRNAs, small regulatory fragments whose presence and absence across lineages can behave like durable signposts. All of them need anchors. A fossil carefully placed, cautiously interpreted, becomes a calibration point. This lineage was here by then. A few points, spread like stakes along the shore, restrain the tent of time, so the wind of rate variation does not take it. But rates still vary. A lineage with short generations can accumulate neutral changes faster. One with long lives can be slower. A small-bodied, warm-blooded life in a later era might tick briskly. A cold, slow, long-lived one ticks like a grandfather clock. Even within a genome, some sites are shielded by selection. Others are free to wander. The modern answer is not to force one tempo but to model many. Relaxed clocks in the careful phrasing, Bayesian methods, softly statistical, let rates breathe from branch to branch while holding the tree upright. The result is not a single age, but a cloud of possibility with a center and a spread. Those clouds, for key splits, tend to drift older than the first unambiguous body fossils. Bilaterians may separate in the mid to late Ediacaran. Major branches within them spill across the Ediacaran Cambrian boundary like waves over a sandbar. In some reconstructions, the earliest Metazone splits reach back further still. A story that includes controversies about which group sponges or catanophores sits deepest at the tree's base, and what that means for nerves and guts and the order of invention. The debates are civil and ongoing. The animals, long gone, do not argue. We leave space for Pat, and the rocks answer. Show me. They show us Trepticnus pedum, those probing burrows that became, by agreement, the signature of the Cambrian's first page. They show small shelly puzzles and elaborate trilobite nations. They show soft-bodied extravagance, where chemistry was kind, earlier than that, in the Ediacaran. They show silhouettes of beings that may sit outside modern animal categories, or may include a few animals in styles that do not map easily to later forms. They show in a handful of places trace fossils that hint at bilaterian behaviors before the boundary, little meanders and dives that feel like tests of depth. They show in some records chemical whispers, biomarkers that have been read as sponge sterols, and then questioned and then read in other ways. The rocks are generous, but they are not eager to exaggerate. They prefer understatement. Between these two voices, genes and stones, sits the idea of a long fuse. In this picture, the roots of animal diversity extend quietly into the Ediacaran and, perhaps earlier, small, soft, simple bodies, practicing the bilaterian grammar out of sight of most preservation. The Cambrian, then, is the moment when that grammar was expressed loudly as architecture, shells, spines, lenses, limbs. When ecologies became structured in ways that leave confident traces, when the seabed's wakefulness and the water's clarity and oxygen's availability combined to make fossils that shout disparity, the breadth of body plans may have spiked early, while richness, the count of kinds, continued into the Ordovician's long swell. It is not explosion versus fuse. It is both a spark thrown into tinder that had been quietly drying for a long afternoon. Evo-Devo, evolutionary developmental biology, offers a bridge. It shows us how old genes can be asked to do new tricks by changing when and where they speak. Heterochrony, shifting timing, heterotopy, shifting place, and co-option, repurposing, make innovation feel fast even when the parts are ancient. A pigment cell's enzyme becomes a lens protein, pressed into clarity. A limb's primitive bud is read by a slightly different gradient and becomes a paddle instead of a leg. A suite of Hox genes that once marked a simple head-to-tail rhythm gains duplicates and divisions of labor. The front becomes more articulate, the middle more modular. In this light, the Cambrian looks less like the sudden appearance of new letters and more like a rash of new sentences. There are deeper hints in our own genomes, conserved non-coding elements that act like switches, turned on and off by proteins that sense position. Syntony, the neighborly arrangement of genes along chromosomes, preserved across vast spans, as if a developmental book liked to keep its chapters in order even as pages were edited. Some analyses suggest old, large-scale duplications in the ancestry of vertebrates. Events that, if real and placed where some propose, could have provided raw material for the blossoming of head and heart and immune conversation. The exact timing and count of those duplications remain debated. We keep our voice low. Even without such dramatic events, small duplications and losses and linkages, one after another, make scaffolds on which to build complexity quickly when the room invites it. Opsins, the light-sensing molecules we met when eyes arrived, carry their own genealogies. Their family tree seems older than the Cambrian, suggesting that the capacity to sense light in nuanced ways predated image-making eyes. Similarly, many pieces of the immune orchestra, many of the cell adhesion glues that let tissues hold, many of the patterning gradients that embryos use like compasses, are older than their Cambrian performances. The surprise is not that bodies became complex, but that complexity felt available suddenly because the stage had been set and the orchestra, already rehearsing quietly, was asked to play louder. Of course, some molecular signals are murky. Saturation, so many changes at a site that earlier states are overwritten, can make deep divergences look more recent or more ancient depending on the model. Compositional biases, the way different lineages favor different letters because of mutation pressures, can pull unrelated branches together dishonestly. Horizontal gene transfer, so rampant in microbes, plays almost no role in animal genomes. But ancient symbioses leave their traces, and endosymbiotic organelles, mitochondria, carry clocks of their own that tick to different beats. The data, generous and voluminous, are not perfect. The practice is to test, then retest, then combine with the rocks, and to let discrepant nodes remain gently unresolved until a new piece of bone or a new line of code clarifies them. Sometimes the mismatch is local and illuminating. A molecular clock might place the split between two arthropod groups just before a time when the rocks tell us a basin dried, continents drew together, currents shifted, a plausible ecological nudge. A fossil gap might coincide with a period when preservation would be expected to be poor, because burrowing was at a new intensity or because sea level fell and the shelf narrowed. The two clocks in conversation explain not only when but why we can or cannot see when. We live with ghost lineages, branches inferred by molecules that have no fossil representatives for a stretch. They are not accusations, they are invitations to look in different kinds of rocks, in basins not yet sampled, in deposits we thought too altered to yield grace. The Cambrian and its Ediacaran borderland are rich in such invitations. Each new exploration of a shelf in a place remote to our logistics, of a slice of shale with a new preparation method, has the chance to collapse a ghost into a face. There is a sweetness in how both clocks affirm the same larger story even as they bicker gently about details. Both say animals, as a way of being, are old, and their visible exuberance as carved and glittering forms took on a new scale around what we call the Cambrian. Both say the ocean's chemistry matters, ecology matters, development matters, chance matters. Both say history is not a single line, but a braid. When you pull one strand, oxygen, calcium, genes, geography, the others tighten or slacken in response. Hold a single image to finish this chapter. On a workbench, a thin section of shale lies under polarized light. Next to it, on the screen, a phylogenetic tree arches like a winter branch. In the shale, a translucent film sketches a limb. On the tree, a node carries a date, with a tilde, a gentle about. A finger points from rock to node and back. The person attached to the finger does not seek to win the argument. They seek to let the two objects tune one another, like a guitar string tuned to a tuning fork, and then to its neighbor. The result is music, imperfect, warm, recognizable, enough to hum to. We will leave these clocks to tick beside each other, trusting that their differences are a kind of stereo. In the next chapter, the sea steps back and the continents lean in. We will listen to the slow engines of tectonics and weathering, to the way mountains gift ions to the tide, to how trace metals and nutrient pulses might have set tempos the genes and rocks both had to dance to. Then a brief interlude of small shelly puzzles before an afterglow into the Ordovician's long brightening. Our pace remains slow, and the night outside our window remains kind. Mountains breathe, but on a time scale we only hear if we lie very, very still. A ridge lifts, green for a blink, then grey, frost pries it open, rain combs it, rivers collect its minerals like careful scavengers. Grain by grain, the continent leans toward the sea. What begins as cliff ends There's taste calcium in a drop, phosphate in a plume, iron in a stain that the ocean translates into appetite, and bone. In the Cambrian neighbourhood, this translation may have quickened. Continents shuffled, suturing here, rifting there, making long shallow shelves like ledges under a bath, transgressions. Sea level easing inland, flooded, broad platforms where light and mud and chemistry could take their time with one another. Each new shoreline was a mouth of sorts, receiving the breath of mountains, weathering, quiet and endless, wrote letters in ions and sent them seaward. Calcium and magnesium came as signatures of rock and ridge. The ratio between them, Midgecay set a mineral mood, aragonite easier in some intervals, calcite in others. Creatures learning to stiffen themselves did not choose from a blank menu. They ordered what the kitchen was already inclined to cook. Phosphate, rarer and potent, arrived in pulses, weathering's little gusts, upwelling's exhalations, nudging productivity, allowing the quick turning of cells into more cells. Trace metals, molybdenum, zinc, copper, tiny keys for enzymes, traveled in low concentration, their availabilities whispering permissions. You may fix nitrogen more easily now. You may detoxify this reactive breath. You may build with silica if the glass drawer is open. These murmurs did not command, but they biased what could be tried cheaply, what could be afforded without ruin. Rivers were the couriers. On slopes newly high they ran fast and cold. Loaded on lowlands they meandered and dropped their burdens in fans and deltas. Where they met the sea, plumes spread like torn silk. Fresh water sitting atop salt, fine particles staying aloft long enough to shade and feed. In bays with headlands to slow the mix, that shade may have made gradients darker near the river, clearer at the mouth, inviting different lives at different distances. Farther out, on carbonate banks, less touched by silt, clarity reigned. There, light bore deeper, the gift to eyes when they arrived, and to filterers who preferred clean water. The ocean offered both rooms, sometimes side by side, a tea-coloured estuary, a blue-green shelf. The planet's deep engine had its own deliveries. At spreading ridges, seawater percolated into hot rock and came out altered, stripped of magnesium, enriched in calcium and metals, subtly changing the global brew. Hydrothermal vents in deeper rooms puffed chemistry into darkness, nourishing gardens the sun never saw. Unlikely Cambrian neighbours to our shallow story, yet part of the same ledger. Even small changes in ridge length and speed ripple outward. More ridge means more hot exchange, which nudges seawater's taste, which nudges shells' preferences, which nudges beaches' sands. The chain is long and elegant. Sea level itself moved like a hand on a dimmer. Greenhouse warmth, likely common in the early Paleozoic, reduced ice, raised seas, flooded shelves. Warmth also stratified the ocean, making distinct layers less eager to trade breath. Transgression invited life onto the platform. Stratification in certain basins withheld oxygen from the deeper parts. Productivity climbed in the sunlit skin, and the rain of that life, its bodies falling after brief days, fed microbes below that used up breath and made other chemistries necessary. The oxic surface, the disoxic middle, the anoxic floor, a three-note chord in slow motion. Within those layers, animals found lanes. Some grazed the interface and ran ventilation through their burrows to steal air for the mud. Some lifted into the clean light. Some endured the murk and made a living where neighbours didn't dare. We can imagine, gently, the continent's arrangement as eddies and gates. The way a narrow seaway can accelerate currents like wind in a canyon. The way a broad embayment can trap warmth and nurture blooms. The way a sill can cap a basin and make deep water old and breathless. The Cambrian seascape likely held all three. Circulation, less a conveyor than a braid. Sorted nutrients with a fussy hand. A coast with wind that drove surface water offshore would invite upwelling. Cold, nutrient-rich tongues rising, greening the shallows, fattening filterers, and perhaps inviting short anoxic spells below as the feast's leftovers sank. Another coast protected and lazy would favour carbonate factories. Quiet precipitation from warm, clear water, sandbanks of oids rolling like beads. Archaeocyathon thickets, lifting little cities that baffle flow and keep larvae close. Weathering also spoke to the sky. Chemical weathering of silicate rocks draws down carbon dioxide, slowly, steadily, tying climate to mountains in a feedback that hums deeper than any season. Raise a range and you give the world a bigger sponge. Grind it down and you ease the draw. In the Cambrian, depending on who you read closely, this feedback may have modulated warmth, gently. The exact numbers are not our business tonight. The flavor is when continents gather and split, when arcs accrete, when volcanoes are earnest. These tectonic habits set the background key in which the ocean composes its nearshore symphony. Trace metals, so small in quantity, can amplify themes. Molybdenum, for instance, loves to be in solution when deep waters are oxygenated. When they go anoxic and sulfidic, it is scavenged into sediments and becomes scarce for the upper ocean. Life that depends on molybdenum to fix nitrogen, turning N2's stubborn bond into something edible, finds the work harder, and productivity shifts to other modes. Iron, delivered by dust and rivers, supports blooms when macronutrients are present. But this micronutrient is not in basins with little dust. Iron can be the whisper that says not today. The Cambrian oceans were not void of such subtleties. They were likely laced with them, though our proxies, trace metal concentrations, isotope ratios, catch the gist more than the verse. Silica rode its own tide, before diatoms later commandeered silica as if born to it. Sponges were among its main borrowers. High dissolved silica encourages glacier forests. Low silica invites other builders to take the stage. If Cambrian shelves saw a gradual decline in silica from seafloor exchange and sponge harvest, that too would have nudged who could live where, and how clear water could become when filters were many. Clearer water is not inherently better. It is simply different, a room friendlier to vision and to carbonate precipitation, less kind to plankton that prefer shade. All the while, waves, those near-surface sculptors, set the geometry of living space. Storm wave base, the depth below which storms rarely stir, drew a broad line across shelves. Above it, beds were often reworked. Below they were quieter. Tube dwellers, that liked to pump without interruption, favoured the lower flats. Sandpipers of the Cambrian world, Scolophus folk, planted chimneys in upper shore faces and trusted resilience. Ripple fields marched like sleepy armies, their wavelength and shape encoded depth, and fetch and wand. Animals read those shapes with their bodies. A trilobite could nestle in a ripple trough and let the boundary layer dull a predator's pressure sense. A lobopodian could avoid the crest where flow would flip it like a leaf. There is a generosity to epiric seas, broad, shallow, epicontinental waters, that we should praise here. They make habitat into a sheet cake, huge areas within reach of light and waves, vast nursery grounds for small experiments. They also make vulnerability, a small sea level fall, and miles of shelf become land, a small rise, and shorelines lurch inland, remaking maps. Cambrian life grew up with this volatility as a given. Perhaps that trained a certain plasticity, a readiness to move, to settle on new substrate, to rebuild a tube after burial, to molt when weather signaled even if the molt was not due. Behavior becomes the bridge between tectonic tempo and daily bread. Can we hold a day in such a room? Dawn, a warm haze from a river mouth. Tea-coloured water stripes the sea, spreading and thinning. In that stripe, plankton thicken, some loving the comfort of nutrients, some disliking the shade and moving aside. Along the front, where river and sea meet, predators patrol. Contrast makes edges, edges make chances. On a carbonate shoal, a little down the coast, weeds tick in the swash, growing skin after skin of lime in the churn. Each roll, a tiny season. Archaeosathas filter in the lee of a low wall, their sieve walls humming with current. In the quiet zone below storm wave base, a field of tubes pumps, the sediment breathes. By afternoon, a breeze stiffens. The surface roughens. Light strobes filterers fold and unfold to the rhythm. Night brings calm, a weak upwelling sighs. Cold tongues lift nutrients. A metre or two larvae rise with them. Feel something like home and pause. None of it is dramatic. All of it is formative. We might wonder, softly, if pulses in this environmental score brief accelerations of weathering, moments when rivers carried a little more phosphorus, times when trace metals were briefly generous, coincided with small bursts of innovation, not as switches, but as tailwinds, a new reef module, taking hold when currents clarified a bay a touch, a shell style catching on where a megatea favored a certain crystal, and predators' teeth tripped on it, a burrow depth deepening because oxygen wriggled a few millimeters further down. The Cambrian shines less like a single star and more like a Milky Way, thousands of faint lights, adding up to a glow, each brightened by the invisible gravity of tectonics and climate, and always feedback. As shells piled into beaches, they made coquinas that altered shoreline shape, which altered wave refraction, which altered sediment delivery, which altered where larvae landed. As burrowers irrigated mud, they changed phosphorus recycling, which altered productivity, which altered oxygen, which altered who could burrow deeper. As sponges clarified water, they strengthened carbonate precipitation, which built more hard grounds for sponges to colonize. Life responded to the stage and, with a beginner's assurance, began to direct the lighting and move the furniture. Hold, for a last moment, the taste of the word weathering. How it suggests decay, and yet feeds creation. A mountain becomes an animal in a chain of patient gifts. The gift is not intentional, it is simply what happens when rain keeps its promises. In the Cambrian, those promises were frequent and kind. Waves carrying their own promises delivered the gift room by room along a brimful sea. We will, in a small interlude next, pause with the small shelly puzzles, those drawers of parts that feel like a toy chest tipped over, then follow the afterglow into the Ordovician, where the long swell of diversity makes the word explosion feel less like a pop and more like a tide. For now, let the mountain rest. The river drop its last shine of silt, the shelf exhale, weathering hums, waves repeat. And in the repeating worlds appear. Before armor became architecture, there was glitter on the floor, a scoop of early Cambrian limestone, dissolved very gently in weak acid, leaves behind a residue that sparkles under a desk lamp, grains of sand, yes, and also a scatter of miniature mysteries, tiny cones and scales, hooks and half-moons, starry pins and roof tiles the size of dust. This is the small shelly world, an interlude of parts. If the Cambrian has a clatter, it begins here, a drawer of spare pieces spilled across the bench. Small shelly fossils, SSF for the late shorthand, do not announce themselves as celebrities. They whisper through sieves. They are sorted with paintbrush hairs, coaxed from droplets, mounted in rows like alphabet seeds. Many are phosphatic, some are calcitic, a few silicious, all hard enough to survive the bath that melts their host rock. And though a single fragment may be modest, together they feel like a vocabulary, the syllables from which later sentences, shells and plates and coats are composed. Some of the pieces suggest houses in miniature. Hyloth cones, the tiniest among them, are perfect little ice cream shells, sometimes with a lid that fits like a thought. Cap-like mollusks, halcyonellids, curve like sheltering hands. Coil hints appear, logarithms so small you could mistake them for a pencil shaving. Other pieces do not look like houses at all. They look like shingles and scales, skellites that must once have fitted together into something larger and alive. You can feel the jigsaw tug, which edge meets which edge. What body wore this male? Hulk-eared sclerites, when found by the hundreds, hint at an animal like a long, low hill armored in overlapping tiles, left-handed and right-handed pieces, mixing along a back that carried spines like measured sarcasm, waxy as plates, leafy ribbed speak of a grazer with a velvet underbody and a bristled caution along its roofline. Chancelloried stars radial, decorative to our eyes, probably studded sponge-like forms, a medieval sparkle in a quiet garden of water. The beauty of these parts is not only their shape, it is their suggestion of a whole that the rock seldom gives us outright. A sclerotomy is the later word for the completed suit, the full arrangement. In the small shelly interlude we mostly hold the buttons and try to imagine the coat. Other parts are mouths or near mouths, or perhaps things that held the world just outside the mouth, tiny cuspate teeth, arranged in sets, are sometimes recovered as if the animal shed them or died in pieces. Some of these protoconodonts, once thought to be the earliest of a later fishy lineage, now soften into different stories, grasping spines, maybe from arrow worm-like predators, bits of a grasping apparatus that never grew a backbone, a ribboned rasp, a radula precursor, is inferred from cap-shaped shells with wear that looks like scraping, though the ribbon itself, delicate and unmineralized, almost never makes the page. In this drawer of parts, verbs matter as much as nouns. Rasp, press, brace, pierce. You can hear actions in the shapes. And then the tomotids, a choir of phosphatic plates that for a long while sat in trays, labelled enigmatic. Micrina, Tanualena, Ekentra bathica, names like bells. Their sclerites range from cones to saddles to tubes, with little windows. As more complete arrangements were found, tubes assembled, living positions guessed, insight tilted. Some tomotids, it seems, sit near the ancestry of brachiopods, those later clam-like purses that filter with ciliated fans. A two-valved life could be built from a ring of tomotid plates, reoriented, simplified, then perfected by habit. In this way, the small shelly interlude becomes something more than a flea market. It becomes a family album in puzzle form. Some SSF drift into the earliest Cambrian already humming with a prelude from the Ediacaran's last days. Cloudina, tube upon tube, stacked like a delicate chimney, grew before the Cambrian boundary and shows borings in some specimens, little attack holes that could be predation or opportunism. Namacalathus with a cup and a perforated wall is another of those late silhouettes in carbonate. Whether we count them as animals in the modern taxonomic sense, they murmur the same thing. Mineral and body had shaken hands before the bright chorus. By the time we reach the Fortunian, the first slice of the Cambrian proper, the drawer of parts is crowded. These parts were useful beyond awe, because many lineages made their pieces quickly and briefly, then moved on. Small shelly fossils became timekeepers. Biostratigraphic flags you could plant in a column and say, "We are here." They travelled, they evolved fast, they left durable breadcrumbs. A rock with proto-Hertzina-like spines might sit in one moment, a bed rich in specific tomatid sclerites. In another, the tiny then became global, stitching far coastlines together in the hands of patient pickers, an hourglass made of teeth. If we lean closer, taphonomy keeps advising. Phosphate loves to jacket small organic forms quickly when chemistry allows. This is why so many SSF are phosphatic, even when their living descendants or presumed relatives are not. The trick is a local one, right pore waters, right contexts. So the presence of SSF in one basin and their scarcity in another may speak to preservation more than true absence. Acetic acid, our laboratory ally, dissolves limestone gently enough to keep phosphatic parts intact. Calcitic pieces survive too, though they ask for gentler hands. Silica stays aloof. A residue dish afterward is a microcosm, a field of odds and ends, a field labourers crawl with needles to gather. The intimacy of this work is a kind of prayer. What did these parts do, day by day? A sclerite field on a moving back made a mouthful unruly. A spine, small in itself, converted a bite into a lesson. Shingles overlapped to produce a flexible wall, a cuticle that could bend yet resist a claw. Conical shells resisted point loads. Cap shells shed strikes like rain. Some plates show growth increments. Microscopic rings that, like tree rings without seasons, record the cadence of mineral arriving at an edge. Surfaces show polish where life rubbed them against house or mate or sand. Minute facets on a cusp show where that, if you squint kindly, reads like a feeding habit in lowercase. Not all small shelly fossils were armor. Some are tubes, the domiciles of creatures that filtered or guarded. Enabarites, with its unusual Triskelion-like cross-section, is a favorite puzzle. A tube with 3 lobes, stacked, a braid made solid. Who lived inside? How did they grow the triple thread? The tube tells you nothing directly of a face. It tells you the craft of a room. Similar questions follow the ornamented cones of hyoliths. some with a device that looks like little arms, helens, on either side of the aperture, as if the animal solved the problem of posture with two props. Even at a few millimeters tall, design assemblages in the field feel like gravel bars of possibilities. A thin bed of lime mud, when washed, could pour 100 kinds of parts into a tray. Next bed down, almost nothing. The difference may be original ecology. One moment, a sclerite rain from a molting ground, another a calm slope far from the armoured. But it might also be taphonomic mood, a pulse of phosphate, a change in pH, a percolation of poor water that saved one day and forgot the next. The interlude is streaky, rich, poor, rich, like bird song in a breezy grove. For a while, through the earliest Cambrian stages, this vocabulary dominates the record. Large, articulated bodies are rarer. Windows like Chengjiang and Sirius Passet are not yet frequent. The sea in the rock's memory is a carpet of parts. Then as trilobites gather into legible nations, as brachiopods settle in by the millions, as sponges and early reefs lift themselves into hardness that does not need acid to free it. The small shelly vocabulary quiets. It does not vanish. It hums under the melody, a harmony you can still hear if you cup your ear to beach grit. But the record's center of gravity shifts from syllables to sentences. Why the fade? Perhaps because animals scaled up their mineral stories, sclites coalescing into larger armors that preserve intact. More often, houses that once weathered into confetti, becoming strong enough to fossilize as whole rooms. Perhaps because chemistry changed in favor of different modes. NGA drifting, phosphite pulses altering, poor water habits, shifting the ease with which jackets formed. Perhaps because stirring intensified bioturbation scuffing and scattering little pieces before they could settle into protected pores. Perhaps because once some predators learned to crunch, the advantage drifted away from tiny armor toward different tactics. Burial speed, thicker plates, the interlude fades, softly, plausibly, like an overture yielding to the main theme. Meanwhile, the drawer of parts remains a rosetta for the early script. Tomatide plates tie quietly to brachiopod ancestry. Waiwak seed and halkierid, sclerites, triangulate relationships among molluscan-grade grazers and spined enigmas. Chancellorid stars remind us that sponges, too, experimented with showy arms. Even misunderstandings have been generous lessons. The protoconodont chapter, those tooth-like elements that carried the hope of very early vertebrate cousins, has taught caution and openness. As interpretations move toward grasping spines of arrow worm-like predators in at least some cases, our larger picture becomes less triumphal and more truthful. The interlude is patient with our nouns. There is also something disarmingly tender about scale. A millimeter-wide cone was a room. A row of 10 sclerites was a fortitude. A cusp that could barely nick your fingertip was a tool that fed a life for months. When we pour the residue and squint into its glitter, we are peering into the economy of small gains, the kind of economy that makes evolution fast when it works. At a ridge, bevel an edge, harden a coat by 1% more, overlap plates by a hair more. The drawer of parts is innovation not in fireworks but in stitching. Let us stand a moment at a lab bench. Imagination lit by a gooseneck lamp. A porcelain dish holds a dark puddle, in which grains drift. A pipette nudges a fleck to the dish's margin. The fleck grips the porcelain with surface tension, then yields. Under the stereoscope, a cone pops into clarity, its growth lines like fingerprints. Next to it, a saddle-shaped plate with 2 broken prongs, beyond a tiny star with facets like weathered glass. A person with steady hands and satisfied patience uses a whisker of a brush to lift the star, touches it to a dot of glue on a slide, and makes a constellation. Later, in a notebook, tidy notes, depth in section, bed number, counts. In the margin, a guess with 2 question marks, and a smile. Science here is not a march. It is a beadwork. Back in the sea, quiet as ever about our systems, the animals that made these parts were carrying on as if none of this would matter. A small slug-like grazer crept along a film of microbial sweetness, its sclerites shed from time to time, and fluttered into pore spaces like scales from a shed coat. A hyolith lifted its lid to feed and set its helens against the substrate for balance, lowering the lid each time shadow passed. A tomatide settled its ring of plates on a firm spot and filtered with a softness the rock cannot keep. No speech, no museum glass, no bench lamp, just lives the size of raindrops making decisions the size of breath. If we call this chapter an interlude, we do so with care. Interludes are not lesser, they are where key changes happen quietly. The small shelly world is a hinge between silhouettes and bodies, between chemistry and ecology. It shows us how a mineral trick becomes a way of life, how a jacket becomes a family, how the sea in its trace metal murmurs and its carbonate moods partners with animal effort to write hardware into software and back again. Soon our long tide will carry us into an afterglow, the Ordovicion's patient brightening, a diversification that feels like sunrise extended. The drawer of parts will still be there, humming under the melody, but our ears will be full of reefs and brachiopod fields and fish beginning their experiments with bone inside and armor outside. Before we go, let one last grain dry in the dish, an impossibly small plate with a single ridge, so slight it is almost nothing, and let us admit that such a ridge multiplied by a lineage could persuade a predator's tooth to slip once instead of grip, and that once would sometimes mean a next generation, a glitter on the floor, a vocabulary on the tongue, a hush that holds more invention than its sparkle admits. Explosions are loud, tides are patient. After the Cambrian's bright crackle, the sea did not dim. It widened its voice, drawing out a long vowel that carried through the Ordovician, a swell that lifted almost everything that could be lifted. If the Cambrian felt like the orchestra tuning, brisk, surprising, the Ordovician plays the theme at full length, layer upon layer, until the hall vibrates. We stand again at a shelf, but it has learned new chords. Filterers thicken into neighborhoods. What were once solitary chimneys and thin fences become gardens, brachiopod fields like careful tilled plots, bryozoan laces knitting into low hedges, crinoid meadows waving feathery arms, each stalk a quiet mast with a crown that combs the passing flow. Echinoderm styles proliferate, crinoids, cystoids, blastozoans, plates upon plates, engineering poise in water that now carries more voices of plankton than before. Tiering emerges, life stacked in levels above the bed. A half-meter up is a different world than a hand's width above the mud, and bodies choose their floors like tenants, sensing light and rent. Reefs return, not as a Cambrian curiosity this time, but as a habit. Corals with chambered cups, tabulates in honeycomb arrays, rogose forms with solitary flares begin to stitch skeleton into city work. Sponges too lend mass and glue. The old archaeocyclothon interlude feels like a preface. Now the wall grows broader, richer in courtyards and alleys. Flow slows in the shadowed rooms. Larvae pause along edges where micro-eddies whisper stay. A reef is architecture turned into ecology. The Ordovician reads like a builder's decade. Out above the gardens, the open water learns to be busy. Graptolites, delicate saws of living cups, float in the plankton, their colonies sketching zigzags that will one day guide field geologists like constellations do. Sailors, plankton diversify tiny cells with ornate shells, small perfumes of chemistry, making the pelagic realm more of a world in its own right, rather than merely the hallway between bed and shore. With food hanging in the water, suspension becomes strategy, and with strategy comes specialization. Gills refine, ciliated fans practice economy, lophophores coil into shapes that kiss the current more thoughtfully. Predators change their gait. Long, straight shells, orthoconic, nautiloids, take the role of graceful spears. In cross-section their chambers record an arithmetic of buoyancy. In motion they are quiet arithmetic turned to poise and strike. They do not need to be fast to be decisive. A shadow gliding at mid-depth is persuasion enough. Benthic lives practice wariness in 3 dimensions now. Jawless fish armored in small plates like starlight caught in skin, thread through the middle layers, not rulers but residents, their presence padding the plankton into a more complex fabric. Down on the bed, burrows go deeper, broader, more baroque. Galleries spool into knots. Permanent domiciles laminate. The seabed's plumbing grows more confident. Hard grounds, seafloors briefly turn to lithified pavements, become common enough that other lives learn to drill into them. The rock keeps neat freckles from borers, round bite marks in a language of persistence. Bioerosion, a slow gnawing, becomes part of the background hum. To live on a hard place is to accept the slow conversation of teeth and acids, of neighbors who make your house their niche. In the shells, ornament changes from charm to calculus. Ribs and spines and nodes are tuned as much to flow as to mouths. A rib can strengthen and also steer micro-vortices that lift silt from a valve's gape. A spine can deter a predator and also lift a body a little higher into faster water. What reads as decoration is often a life's minutes saved. Less clogging, more feeding, less rolling in storms. Efficiency wears beauty like a well-cut coat. Why this swell? Perhaps because the stage grew wider. Epicontinental seas spread across continents. An inland ocean feeling like 1,000 shelves stitched together. Perhaps because oxygen's reach deepened a little more, allowing community layers to stack higher and metabolisms to run brighter. Perhaps because the planktonic realm matured. More producers aloft means more rain of food and more livelihoods. Built upon that rain, perhaps because ecosystems learned the trick of tiering, using the same square meter of space several times over. Vertically, like a forest, the drivers feel braided. Climate, chemistry, geography, genes, all tugging in the same direction for a while. The Great Ordovician biodiversification, as later pens will name it, is not a single bloom but a series of crescendos that add up. Diversity climbs, disparity broadens further, provincialism appears, different faunas greeting different basins like dialects. A shelf in what will one day be Gondwana hums in a different key than a shelf on Laurentia. Currents, temperatures, and accident make neighbors into distinct choirs. This patchwork is good for the sea. It spreads risk, multiplies solutions, makes the whole more resilient to a storm in one room. Specialization increases without fragility, at least for a while. Trilobites, those steady metronomes, adapt to the new architecture. Some grow spines like hedgehogs, perhaps deterrents, perhaps stabilizers. Some refine enrollment to a tight lock. Some go small, and many, grazing in interstices among briar-zoned twigs. Some push outward onto firmer sands, learning speed enough to cross the open. They are no longer the only faces, but they remain good readers of the room. Their tracks Cruziana still, but different, change with substrate and habit, a script evolving with the script. On the reefs, partnerships proliferate. Small organisms settle on others, epibionts writing on epibionts, until a surface is a palimpsest of lives a few millimeters deep. Coloniality spreads, bryozoans, corals, graptolites, forms that treat an individual less like a solitary self and more like a note in a chord. A colony can place some mouths in the sun and others in shade. It can recover from bite and break. It can send fragments to start new homes down current. The Ordovician Sea has learned to be both populous and communal. The sound of the water changes too, if you'd like to imagine it. Over carbonate banks, odid shoals tick louder. Over crinoid meadows, the faint clicking of plates meeting in current when a gust passes. Over briar-zoned thickets, a velvet rustle. The chemistry learns new equilibria. As filters become forests, the clarity in some bays increases. As reefs baffle flow, sediment settles and makes rooms for softer tenants. As deeper burrowing extends oxygen's fingers downward, nutrients cycle more rapidly between mud and bloom. Feedbacks multiply. The sea edits itself. Not everything is ascent. The late Cambrian saw pauses and regional thinnings, small stumbles in the brightening. Even the Ordovician swell will meet a sudden weather, a coolness that gathers in the south into ice and drops the sea for a time, pruning edges. But pruning does not erase the experiment. It trims it. After, in new arrangements, many themes return. The afterglow implies a light that can be dimmed, and yet seen again. Take, as a closing day, a single cross-section of shelf during this swell morning. Plankton wedge into a green ribbon along a front. Brachiopods open like purses. Crinoids stir. Midday, a nautiloid glides across the street above the houses. A school of small armoured fish threads. A lane. Trilobites pause in the lee of a bryozoan hedge as a gust of flow lifts sand. Evening, graptolite chains drift a little lower, perhaps sensing something that is not a word to them, but is a shape in the water. Cool, rich night. The reef's courtyard glows with plankton. Larvae hang like dust motes in a lamp beam. Burrows pulse in the distance. A storm line flashes, and then the thunder travels underwater as a pressure sigh. The next day, another layer on another body, another ring in another cup. The swell is patient, and patience leaves thick books. The Cambrians dazzle taut possibilities. The Ordovician's afterglow turns possibilities into neighborhoods. By the time this chapter bows, the sea has learned to be crowded without chaos, to stack lives without smothering them, to make room by building room. Our own story, quiet vertebrate threads thickening into bony sketches, has begun to hum in a low register here, almost beneath hearing. In the final chapter we'll place an ear to that hum, and to the toolkits within us that carry faint memories of these old discussions between seawater and flesh. For now, let the swell roll, long assured, silvered by small waves. The bang has become a tide, and the tide, unhurried, arrives.